はい。おはよう。
Good morning, ladies and gentlemen. And thank you for taking time to participate in the Robot Revolution and Industrial IoT International Symposium 2024, despite your very busy schedule. My name is Nakatomi, and I represent the Robot Revolution and Industrial IoT Initiative. Today, I have the honor of delivering the opening remarks for this international symposium, which is co-hosted by the RRI, the Ministry of Economy, Trade and Industry of Japan, and Federal Ministry of Economic Affairs and Climate Protection of Germany. As you can see on the screen, this event is also being sponsored by a number of supporting companies. On this occasion, I would like to express our heartfelt appreciation for their support as well. This symposium first took place in 2015, and this marks the 10th iteration. Global leaders and experts have come together to explore advanced cases related to industrial IoT and to discuss the future challenges and solutions facing our industries. The theme for this 10th symposium is Call for Action, Manufacturing Transformation for Social Innovation. In the following sessions, we'll have sub-themes. The first session will be titled Enabler of Manufacturing Transformation Data Space, which will introduce how digital ecosystems are being formed in the manufacturing sector and outline the expectations participants have for the engagement. In the afternoon, session 2 will focus on industrial sustainability, representing trends from Europe and United States on common challenges such as improving labor productivity and addressing the climate crisis. We will also examine the challenges each country faces regarding digital initiatives such as DX and AI applications, and discuss issues that require international collaboration. Session 3 will provide a progress report on the collaboration between Germany's Plattform Industrie 4.0 and the RRI. Japanese and German experts will share updates on discussions surrounding international standardization, industrial security, business ecosystems, and since last year, industrial data collaboration. Following the 3 sessions, we will also be having a networking opportunity starting at 6:30 p.m. at the restaurant Hikage on the 2nd floor of this very building. Light meals and drinks will be provided, so please do join us. Now, I would like to officially declare the opening of this international symposium. To begin, I would like to introduce Mr. Nakajima from RRI, who will facilitate session 1 and moderate the panel discussion. Nakajima-san is responsible for Working Group 1, the Manufacturing Business Transformation Working Group through IoT at the RRI Secretariat. Thank you, Nakajima-san, for your time.
Nakatomi-sama,
Thank you, Mr. Nakatomi. So we would like to begin. But before entering the first session, there is one request that I'd like to share. We are going to have pretty lengthy panel discussion to make sure we have good interaction. When you ask questions to speakers and panelists, since there are many audience participating online, please use the YouTube description. You would find the link there from which you can jump onto the site where you can ask questions. That is the Slido application. We'll be able to accept your questions in Slido. So your questions, please identify your name and your affiliation. Before writing your questions, we'll be looking through your questions and try to incorporate your questions into our panel discussion. So without further ado, I'd like to invite the very first speaker. We have Mr. Markus Hess, Deputy Director General of Federal Ministry for Economic Affairs and Climate Actions. The title is Necessity of Industrial Data Sharing for Future Growth. So Mr. Hess, please take the floor.
Dear Nakatomi-san, ladies and gentlemen, minasama. My name is Markus Hess. I'm the Deputy Director General of the Federal Ministry for Economic Affairs and Climate Action of Germany, and I'm deeply honored to attend today's meeting. I want to thank the RRI for the kind invitation for this event. This year, we're celebrating 12 years of Industrie 4.0. In this time frame, Japan, especially the RRI, was always a trusted, reliable, and respected partner. RRI itself was founded 10 years ago, and I've been on this journey for 8 years, so we all together have a long way behind us and a long way in front of us. This should illustrate the long way. Here we are. As you can see, we've started 2011, but the main action since 2015 and ongoing. The concepts created within the global Industrie 4.0 framework are remarkable if you look at the milestones on the timeline. The platform Industrie 4.0, together with its international cooperation partners, was able to set up or to support multiple successful initiatives with an outstanding footprint on a global scale. Just to name a few: the Asset Administration Shell, Industrial Digital Twin Association, OPC UA, Labs Network Industry, Standardization Council Industrie 4.0, and if you look at the timeline, after 2019, the X is there. It's Gaia X, it's Catena X, it's Manufacturing X, and now, today, it's Factory X, and many other initiatives and projects. I like to thank Japan, government and industries, and the RRI for their valuable contributions. Without you, we would not be where we are today. This is true on the bilateral basis, but it's also true on a multilateral basis. Together, we share the view that Industrie 4.0 is a global concept, as industry value chains are global. International collaboration, supported by a strong community of contributors from businesses, governments, and academia, is the basis for the success. Just together and only together, we can succeed. Today, we can build on the trustful exchange of concepts and ideas around the globe. One concept is that Industrie 4.0 or smart manufacturing is fully data-driven. Today, but even more in the future, no data, no data treatment, no business. The underlying concept of industrial data ecosystems highlights the tremendous potential of trustful and federated utilization of data. These ecosystems will strengthen the resilience and sustainability of global supply chains. And even more, it is key to set the future competitiveness of our industries in all sectors. Data only has value if we are able to enable it across sectors. Its value can increase exponentially if you use data together with business partners. To be successful, we need, to our conviction, three things. First, a common global systemic approach. Second, a broad adoption of industrial data ecosystems and the expansion of digital infrastructure. And third, openness, transparency, and the use of open source are essential. The German government will continuously support the development of sovereign industrial data ecosystems. To achieve this, we need to set a common regulatory framework and standards, a technical base layer where shared services can be easily used. Every industry sector should be integrated step by step. But these must also be international compatible and globally operational. Here comes International Manufacturing X into play. We introduced Manufacturing X as a truly international initiative from scratch. It will develop and implement scalable concepts, how to utilize data along the value chain, while users keep control over their data. Your data, your decision. Trust and benefit for all participants are essential for its success. We think it's important, connection of data of different manufacturing value chains across industries and countries, enabling innovative solutions across the value chains in an interoperable and sovereign way, and the connection of country-specific interoperability frameworks and setup of common standards. Dear ladies and gentlemen, today's symposium is the perfect ground to understand the new concepts developed in the last year and the achievements made. I would like to encourage the companies and experts to take advantage of the opportunities for cooperation to ensure the global interoperability of various solutions and technologies. I wish you, from the deepest of my heart, a fruitful and successful symposium. Thank you for your attention. Arigato.
様ありがとうございました。次の講演者はですね、マニファクチャリング X のメンバーでもあり、ピア 4.0 の
Thank you very much. Moving on to the next lecture. We have Mr. Tomas Hahn, a member of Manufacturing S and a fellow at Siemens AG. The title of his lecture is Making Manufacturing X International. Mr. Hahn, please begin your lecture.
It's a real pleasure after the opening from my side to start with the first presentation about international manufacturing or Make Manufacturing X International. Like Markus has explained a little bit the journey which we have taken, and you have seen also the different milestones where 80–90% we are doing together with Japan when you are just calculating the years about the cooperation and since we are existing. Also my name is Tomas Hahn. I'm a fellow, Siemens fellow at Siemens as a company, taking nearly just from the beginning in my job outside of Siemens, taking care for Plattform Industrie 4.0 Manufacturing X initiative, and inside, as you can imagine, also for the technology aspects which we are doing in the company, with the aspects like Markus has mentioned regarding competitiveness, resilience, and sustainability. But let's start, coming from industry, let's start with two examples to make it a little bit more touchable, and then I will dig in a little bit about the concepts, what we are doing together, what are the tasks we want to achieve together, and how we set this all up. And I have also to say a special thanks to Nakashima-san, because we are working super closely in this environment together to get it done together. But let's start with two examples or three examples. Well known, I think everybody in the room is aware of this example, but it's shown quite well why data ecosystems, data, the use of data, and to get value out of the data to improve something or to do or to start something is from high relevance, and in this case also for industry. And I give you two examples here at the first slide. One is when you're thinking about CO2 emission reporting and optimizing, because at the end we have to look how we reduce this. And when you're looking, we have several representatives from industry. When you're looking at your own shop floor, you are seeing maybe, depending what you are producing, 10 to 20% of the CO2 emission. And you can imagine the 90 or 80% is in the upstream and downstream. And when you really want to have an overview about your emission respective, when you really want to have an optimization for the emission to reduce the CO2 emission, then you have to look at the complete chain or value chain or supply chain, however, what is needed, depending what you're doing. Also meaning we have to look to the left and to the right and to get data transparency around. Second example is regarding battery. When you're looking at a battery and the one of the other regions are highly depending on rare material. But the good thing also on batteries are you can recycle a lot. You see here a number 96, 95%, also high. And you can imagine this is also improving then our dependency or reducing our dependencies because we can recycle a lot. But also this is only possible when you have, let's say, and Markus has mentioned also the digital twin, when you have the complete overview, when you have the passport, how the battery is produced, used, and then you can optimize, the recycling to put it into a circular economy. And only to get this a little bit more touchable, only to see a little bit, you see here, it's an example from Catena X, in X projects in the automotive area. And for sure, battery optimization on the use to optimize the use of the batteries, but also to collect step by step the different information exactly to have this potential to recycle or to better use the battery. You see here an example from a battery passport. You see it how it's going along the complete chain from the mining up to the recycling. I will not touch in the detail. And on the other side, you see some kind of categories where you collect the data depending what you want to do. And you see here also how additional information are increasingly collected, stored decentral, especially in the example of a battery, this is sometimes, well, very often is in a car built and is somewhere, but it's really collected consequently about the different steps, and you get here the information from the partners very quick. This is only to give you one touchable example why this is so important to have this data transparency. This was 2 use cases. I am very sure in this room we will collect hundreds of use cases in doing this, but really is only some kind of, to setting a little bit the scene, what is driving us. Other example is, security topics. This is one of the use cases which we are touching in the Factory X project. Catena X was automotive. Factory X is exactly going down to the machine tool building industry, going down to the shop floor, where we have some kind of concrete use cases, where you have on the one side the horizontal, and on the second side the connectivity down to the vertical down to the shop floor. And to collect the data and to have on your system, and the one of others knowing this, to fulfill some kind of, in Europe called Cyber Resilience Act, so that you can say what status of the software is on your device. Is this actual security software installed or not? So we are obliged to doing this. This is one of the use cases which we are targeting in factories. It's only to give you 2-3 examples why this is important, why data transparency is important, how we are doing this, and how we are doing this together, which I will touch on some slides later. Going back a little bit about the general needs we have. We have here, and I touched this before with the battery, we have some kind of deployment, depending what is needed, can be close to the production line, can be close to the cloud. It's depending what you want to achieve with your use case or with your business case. Data sharing, I think I mentioned above before, how this is done in the 3 use cases and why this is needed. And, you know, to get it done, you have to look regarding interoperability. So this is somehow the right column, the right topic. But, and this is for me one of the most important sentences on the slide, nobody can do this alone. So we have to look together how we are doing this in a global way, how we are doing this and drive interoperability, respecting local needs and local environments, local infrastructure, and also needs from different verticals, but looking how we can achieve a certain level of interoperability, which we can do together. And I have to say, we have yesterday evening during the dinner a short discussion about Japanese and German attitude to address topics and engineering tasks. We are in this case quite similar. I will exclude, and this is a German talk, about the train system in Germany. I apologize for this, but when you're looking to the engineering stuff, you know, we are quite on a, have a similar attitude in doing this. And that's the reason why we have here over years a very good cooperation and impactful and with a lot of results. That's what we have to do and how we are doing this. And you see here, we have different manufacturing domains. You see here around the circle, you see the car, which was the example for Catena X. You see a robot system on the left side. It's more a symbol for Factory X. You have the chemical elements on the left side, where we are speaking about material passport and chemical processes. You have energy, you have food and beverage, and aerospace, and. Also we have a huge bunch of verticals, which we are, and that's an important topic in the middle, doing together in the International Manufacturing X, addressing this together, looking what are interoperability needs and how we can address this together. International Manufacturing X is an initiative, and as mentioned before, Catena X, Factory X, Semiconductor X are projects to implement the principles in an interoperable way for the specific vertical application. And what we want to do, and it's not a surprise because Markus has mentioned this, what we really want to do is to look resilience. It could be on the one side a supply chain. As we know, during the COVID crisis, we have several hiccups in companies. I can tell you also by myself how we handle this to make this more resilient. Can be also, but we are touching this in the afternoon more regarding skills, availability, also to have the know-how, the people together, some other aspect of resilience. Sustainability, I think I touched this before. And last but not least, competitiveness. For sure, this cooperation helps Japan, helps German companies to be more productive. And I was quite happy that today in the morning when Kaidan Ren was an article in the press exactly addressing the topic about the competitiveness and also data sharing or data transparency, and also regarding CO2 mentioned what to address. And I think internationally, and I think we are here on a very good way together. We have some kind of overall picture how we are doing this. I mentioned a little bit the attitude, the use cases, but we have somehow also to sort it out. You have here on the top level, again, the impact, what we want, great, sustainability, resilience, and competitiveness. Then, you know, we can do a lot in optimizing existing processes, but we can do much more to find new business opportunities. Could be in an as a service, production machinery as a service, could be also an environment where you can use or install new applications. You see the use cases. I think I touched 2 before, but what we have to look for is for shared services. And I see here Otto-san, for example, here in the room. Since years we are working together on the OPC Foundation. We are both on the board of the OPC Foundation. You see here, we are living this international collaboration since years for the reason like I mentioned before. How is then implemented? How is then realized in reality? How is again here respecting the local infrastructure and also competitive solutions. This is somehow done in their technology base level. So it could be different. You know, we have the discussion in the last years, only to make it quite clear. Use cases is somehow Confinity, Catena X, which is some kind of looking in a pre-competitive environment, what is needed, what are the standards. The operating model is, for example, in this case with Confinity X, which can be in Japan, for example, different. And last but not least, in doing this here to drive interoperability. So, sometimes, go back. Sorry for this. In a nutshell, in this international cooperation, we have 3 layers what we want to do. Exchange what we are doing, knowledge, learning from each other, knowledge transfer and learning from each other. Think about the examples which I mentioned before. To look what is the infrastructure, think about my words before, and for sure looking how we can define common standards, interoperability to get it done, respecting the different environment, the different needs in the countries, respecting also the different verticals, and for sure giving also the company some kind of environment to have a competitive solution. How we've done this, I can make it super short because Markus has showed this slide before. We're doing this between us in deep joint projects, like you have seen before. But we're doing this, let's say, also on the international level from Americas over Europe to Asia. And I'm super proud because exactly 1 year ago, we launched this International Manufacturing X Corporation. You see this with a yellow box, a green box. We both last year at the RRI Symposium doing this and now making the next steps. You have to put it inside an overall picture. I will not touch this picture because the experts have spoken about this. And Nakashima-san, together with Klaus, are working in the background. I would only, and this is my last slides, to touch one of the elements I have shown before at the beginning. 3 use cases, but when we're going into, you see here 11 use cases, for example, which we're touching in the Manufacturing X environment in the project Factory X. You see here the information update and change services, that what's exactly the use case, what I have done in detail a little bit before. You have seen the carbon footprint topic. You see here also where, let's say, a product passport, think about my example, is needed. And you have the foundation, like said before, and one topic as an example is for sure trust anchor, how we have trustness, how we are doing this, how we are handling this together. Many, many thanks, and it was a real pleasure to make the opening here. Hopefully I have given you some impression what we are doing, use cases, why we are doing this, and how we are doing this in an open, collaborative way, and really looking forward for the next steps. And I'm very optimistic that we really achieve a lot together. Many thanks, Nakashima, many thanks to all of you.
Thank you. ハーン様ありがとうございました。
Dr. Hahn, thank you very much. The next speaker is from Fraunhofer ISST. We have Director of Fraunhofer ISST, Professor Boris Otto. His presentation is titled Interoperability Within and Across Data Spaces. Professor Otto will join us online remotely from Germany. Can you hear me?
I can hear you all well. Thanks for having me. Can you also hear me?
Yes, yes. So please, the stage is yours. Please start.
Yes. Let me quickly share my slides, and then I will start with my presentation. Just a second. So now you can see my screen in full screen mode, I suppose.
Yes, perfect.
Very good. So, very good. Let me just get rid of this one here. I hope you can see it. I think the Zoom settings is blocking this a little bit. Let me just do it once more so that I only share, let's say, the application. I think that's probably more suitable then. Can you see it now?
Professor Otto, when you share the screen, please turn off the optimization of the video.
Which should I turn off? Let me just.
Please.
Like this?
Yes.
Yes.
Now it's okay.
Okay. Okay, very good. So let's, first of all, thanks for having me. And also, I think it's a good opportunity to, let's say, touch upon what Thomas Hahn just said. Because when we want to address, let's say, the challenges that we are confronted with on a global scale, what we need to put into place is cross-border data sharing. And then furthermore, we would also be required to achieve interoperability within, but also across data spaces. And I would like to use the next 20 minutes or so to elaborate a little bit on this. So what I prepared is basically 3 points that I would like to discuss with you. First of all, let me come back to the business rationale, the business case even for industrial data sharing, because data sharing itself and also data spaces are not an end in itself, but they are a means to achieve certain goals. And I would like to come back to that once more in order for all of us not to forget this. Then I would briefly outline a little bit how that also informs the establishment of common European data spaces, which are, of course, designed to foster data sharing and innovation from data within Europe. But I would also like to stress that that also goes beyond Europe. And which then brings us to the third point that I would like to touch upon, which is data space interoperability. If we start with a very important industry, I'm sure both in Europe, in particular in Germany, but not less in Japan, the automotive industry, then we can identify a couple of business drivers for industrial data sharing, which are here depicted on the left-hand side. There is, let's say, the transformation towards the circular economy. And in order, let's say, to also achieve new forms of mobility, for example, electric mobility, it is a necessity that we change our current production system from sequential value chains towards a circular economy, because it's a matter of fact that otherwise we would not have, let's say, enough resources and raw materials, for example, scarce earths, and also raw material for batteries in order to fulfill the demand for electric mobility. So if we don't enter and embark into a circular use of components and materials, we will not be able to fulfill the demands that are out there, let alone, let's say, of course, requirements when it comes to recycling and also avoidance of waste. A second big use case comes along with traceability and sustainability. And I should say that there is lots of discussion about the carbon footprint of products, which is often, let's say, driven by compliance reasons. But this is not the only motivation for making sure that we are able to report on a very detailed level carbon dioxide emissions that occur in the production and distribution of systems. But in contrast, or on top of that, it's also a customer demand. OEMs, so the brand owners in the automotive value chain, require their suppliers to be very specific and give them basically, carbon footprint intervals, so to say, windows for their particular components. And that requires suppliers to be able to calculate not only on an average basis, but on a very detailed basis, the carbon footprint of a certain component, for example, a rain sensor, which is produced in plant A, for example, in Germany, or in plant B, for example, in Turkey. So that is a requirement not only by the law, but in fact also by the customer. And of course, there are traditional use cases like quality management. Still, enormous amounts of money are spent for recalls, which do not affect the entire batch, but only a couple of, let's say, individual products. But still, we need to recall huge batches, and most of them, let's say, not necessarily. By the way, those use cases on the left-hand side are not only important for the automotive industry, but touching a little bit upon what Thomas Hahn earlier said, they are pretty common throughout or across all manufacturing industries. So we have lots of scaling potential here because, as I said, they hold true not only for automotive, but more or less for all manufacturing industries. However, in the automotive industry, we have the specific situation that we have relatively complex products that we manufacture. And of course, still a very low vertical range of manufacturer in the case of the brand owners, the original equipment manufacturers. And I say that because it's clear when you are required to, let's say, collect detailed information about not only the car itself in this case, but all the individual components, and 75% of the components basically are supplied by your network, then it's clear that you have to team up, right? So you need to engage with the entire ecosystem, with the entire value network in order to meet the demands in terms of providing the required information to embark into a circular economy or to report on sustainability issues, for example. What we have then done, we studied a little bit, let's say, the incentives and barriers of interorganizational data sharing. And there are a couple, let's say, you can basically also categorize them in terms of technical aspects, economic aspects, and also social aspects. And there are, of course, a number of things that companies want to achieve, for example, common standards and vocabularies. Also, let's say, the ambition to overcome data silos, not only within one company, but also between companies. And of course, and the eternal goal, so to say, to have improved and seamless processes. But on the other hand, there is a fear that there will be too many standards, for example. Another incentive is also to engage in, let's say, more in-depth business collaborations, which we have just seen, for example, in the circular economy. But a barrier might also be, let's say, integrating smaller and medium-sized companies. So there is, let's say, a large field of tangents when it comes to international interorganizational data sharing. And I should say that, let's say, finding this balance between the benefits and also the risks on the one hand side, and also the interest of the individual company and of a value network as a whole is, let's say, what drives also, or what has driven the development of the European data strategy. Talking about the European data strategy, I once more took, let's say, this quote here from Ursula von der Leyen when she started her first term. And also by then, it is now 4 years ago, she called for the establishment of common European data spaces, which are seen as the key or strategic instrument to foster cross-company data sharing, and in doing so, increasing the reuse of data, and in doing so, also making sure that the value of data can unfold. And I should say that in the current, you might have known that basically the election took place for the European Parliament, and we are having a new commission these days, and that the European data strategy is transformed into something which is coined the European Data Union. So it will even be, let's say, intensified in terms of making sure that data not only plays an important role as a resource in the European Union, but is more frequently shared for the better of individual companies, as I said, but also for the better of entire communities, value chains, and to a certain extent also the society. It is important to understand that the data strategy materializes in two streams mainly. On the left-hand side, we see, let's say, parts of the regulatory framework that had to be put into place. So it's basically defining the rules of the game when we talk about a fair data economy in Europe. But on the other hand, and this is what I'd like to stress right now in this talk, is, let's say, the call for interoperability. And once more, the strategic means to achieve interoperability and reuse of data is common European data spaces. Why am I qualified, so to say, to speak about the European data strategy? Well, I have the privilege, the honor, and also the pleasure, I should say, to coordinate the European Data Spaces Support Center. And in that role, I'm also, I have an observer seat in the European Data Innovation Board, which is, let's say, why I might be able to reflect also on these kind of things. So coming, let's say, closer to also the core of, let's say, today's talk, if we translate this overall strategy into fundamental or essential requirements for the European data spaces, we would come to, let's say, two major aspects. First one is trust on the left-hand side, and trust materializes basically in trust between the participants of a data space. So you need to be able to trust the guy who is requesting your data, even though you haven't known him for, let's say, decades or so. And the other thing is that you trust, on the one hand side, in the data. So is the data free of rights of third parties that I'm getting through a data space? And on the other hand, also from the perspective of the data provider, trust that the data is not misused. And that is something that we also have seen in this little study that we conducted before. People want to prevent malevolent use of data to happen. So trust is one thing. And the second major requirement is interoperability. And what I try to do is to apply, let's say, within data spaces, and you can see here the footnote number 1, the so-called European Interoperability Framework to the various aspects of data spaces. This is, in my point of view, a quite, let's say, instrumental tool, functional tool, because it identifies 4 layers. The first layer is the legal layer, and, legal aspects within the European Union have been, let's say, sorted out through the regulatory framework, as I just mentioned, for example, the Data Act and the Data Governance Act. And when we talk, in order not to anticipate too much about, let's say, cross-data space interoperability or even cross-border data sharing, of course, we need to make sure that, let's say, also the regulatory frameworks match, which apply to the sharing of data. The second layer is then the organizational layer. And usually this is about, let's say, how certain processes have to be established within data spaces, what participants are allowed to do, and according to which overarching rules. We have a couple of, let's say, frameworks in place, for example, from the Data Spaces Support Center, which I will touch upon later on, but also from the International Data Space Association, the so-called rule book. And I know that, let's say, there is close alignment between Japanese activities on the one hand side, and of course also European initiatives on the other hand. Then we come to, let's say, the third layer, which deals with semantic aspects of interoperability. And when we talk about data spaces, we need to make sure that interoperability on this level can be achieved with regard to the identities. So, we have different identity schemes in place. In Europe, we will be having very shortly eIDAS 2. If I'm not mistaken, I heard that there are similar activities going on in Japan. So we need to see whether these kind of schemas really map in order to make sure that international data sharing can be achieved. Also, we need to make sure that the claims that are connected to certain participants. So, my claim, for example, is that I store the data only in Europe, for example, or that I possess, let's say, a TISAC certificate, all these kind of things, that these articulation of claims is also interoperable and can be verified not only in one data space, but also in several data spaces. Then, of course, if I want to publish my data, we need to think of interoperability of the catalog schemas in order to store the metadata. We need to think of interoperability of usage and access conditions for the data, for the resulting data contracts, and of course for the shared data itself. And then, while semantic aspects are related to the meaning of the data, which is usually depicted in vocabularies or, let's say, semantic information models, we also need to achieve interoperability on, let's say, even more technical aspects when it comes to, let's say, protocols and data sharing specifications. And that must happen both within, but also across data spaces. I then also did the exercise to go through what happens really on two sides of a data sharing transaction, which is on the one hand side, the data rights holder, and on the other hand, the data user. I don't want to go through all the details, but just touch upon a couple of things, which basically depict the fundamental requirements when it comes to data sharing agreements. For example, the data rights holder must be free to grant rights or not. They must be able to publish their metadata and so on and so forth. And on the other hand, as mentioned earlier, the data user must be able to trust that the legal status of the data access, shared, and reused is clear. And also, let's say that the data provider really has a license to act on behalf of the data rights holder, and so forth, and so on and so forth. This is also not only just a theoretical concept, but has been implemented, for example, in Catena X. And I should say that Catena X is not a project anymore. It's there, it's live. Companies use it for, let's say, business critical operations. So use cases are implemented with Catena X. And if they would be broken, then basically production would stop. So Catena X is at the heart of the automotive industry. It's live. And you can see here interoperability also depicted in the so-called governance model, which identifies so-called flight levels, which are pretty close to the the interoperability framework that I just introduced before. So we have this 30,000 feet view for, let's say, the overall governance framework, which also includes, let's say, regulatory aspects. And then it goes down to the specific data sharing layer. I talked about the blueprint for data spaces, which is elaborated and developed by the European Data Spaces Support Center. It's basically, a template that can be used for the creation and development of data spaces. It includes both technical building blocks, but also organizational and business building blocks. And I just came back. That is also the reason why I unfortunately can't be with you in face-to-face and presence. I just came back from one of the general meetings of the Data Spaces Support Center that we had in Belgium. And we stressed the fact of cross-data space interoperability. So the next version of the blueprint will also have a dedicated section for cross-data space interoperability. Yes, I should come to a couple of, let's say, very concrete activities that I want to make sure that you are aware of. There is an initiative in Europe under the umbrella of the CEN. So CEN stands for Centre Européen de Normalisation, which is basically the European Standardization Agency, where we define the fundamental requirements for a trusted data transaction as they are used, for example, in data spaces. And this is also what I referred to when I talked about semantic interoperability. You can see on the left-hand side these, let's say, couple of, let's say, life cycle stages of a data transaction between a data provider and a data user. And we need to make sure that interoperability can be achieved for all of the 6 life cycles. I think they are not very specific. They hold true not only for Europe, of course, but are very generic. So that's also the reason why I presented here. And when we, let's say, talk about, let's say, closer collaboration within the international manufacturing X environment, but also, let's say, when we talk about how to achieve, let's say, data sharing between Uranus, Catena, and other data spaces, for example, we need to address, let's say, these 6 life cycle stages at least. Yes, let me also make you aware of some very important things when it comes to achieving standards for interoperability. So there is a lot of activities going on the specification side. For example, the IDSA Association published earlier this year the data space protocol in the first stable version. This has been taken up by the open source community under the Eclipse Foundation, and there are a lot of, let's say, members which represent individual companies, but also entire ecosystems, which basically join forces in order to develop, let's say, the software. And further on, we have then the opportunity, due to the fact that the Eclipse Foundation has a category A liaison with ISO, to bring that relatively quickly to an ISO standard. And we are currently working on the first standard of a standards family, which is AWI 2151, which lays the fundamentals for data space characteristics. And this will be then followed up by the next standard in that family that basically makes the data space protocol an international standard. And I think this is something, and Tomas said that earlier on, where we all have to work together, because the challenges that we are confronted with are ones that can't be solved in Europe or Japan only, but that require a collaboration on a global scale. Yes, perhaps a couple of, let's say, final thoughts about different ways to achieve inter-data space interoperability. So I think we can, in general, identify 3 patterns. So we could, on the left-hand side, leave it a little bit to the individual participants, if you may. So assuming, let's say, these icons here depict 2 data spaces, and you have a couple of, let's say, participants in each of those. You can basically, just leave it, as I said, up to the participants to walk through these 4 layers, legal, org, semantic, technical, to sort it out by themselves. This is probably not the, let's say, the best and the most, let's say, smooth way, but there may be options where this is suitable. Then we have, let's say, overlapping data spaces where the interoperability task, I should say, could be done by intermediaries. So service providers like, for example, Cofinity X in the case of Catena, but also others, Fujitsu, for example, with whom we collaborate on this matters in order to make sure that, let's say, the interoperability task is, let's say, done by one for all. And we could also imagine a third pattern where we do not necessarily have 2 separated data spaces, but rather something which is nested. And I should say that this model is closest to the original definition of a data space, which basically did not know, let's say, a definite boundary of a data space. So assuming that we have, let's say, a higher order data space, which defines, for example, the organizational interoperability framework and also the legal framework, and gives specifications also on the semantic level, this could just be, let's say, inherited by smaller sub-data spaces in this overarching data space. I'm not so sure whether that fits basically, let's say, in our case, but at least that is something which is very closely related to this idea of common European data spaces, because we have in Europe a number of, let's say, individual data space activities in one domain, for example, mobility, and they eventually need to form altogether an overarching European mobility data space. I also know that there are discussions around, well, how many Catenas should there be? Since I'm also in the board of directors of Catena X, I believe the best way is that there is only one Catena, but there will probably be more, let's say, individual instantiations when it comes to certain services, which then all follow, let's say, the overarching Catena rules, if you may. So this is, I think, something that will also be touched upon in International Manufacturing X. And I think Tomas said that, Tomas, you said you were very proud that this is now in place. And I can say I would like to support this, because this is really a great opportunity for all of us, because we have a platform, a collaboration format where we can drive these things further. And I can say that I'm very glad and very happy to be part of this initiative. And I'm looking very much forward to the next steps in, let's say, collaborating with all of you. And I hope you received a couple of, let's say, fresh ideas through my presentation. And I'd like to thank you very much for your attention. Thank you.
Thank you. Otto 先生、ありがとうございました。
Thank you, Otto-san. Dr. Otto will be coming to the panel discussion. Next, allow me to introduce the next speaker. It is the co-chairperson, Working Group RRI and Senior Strategist and Control System Platform Division of Hitachi Limited, Mr. Naohiko Irie. His title of presentation is Industrial Data Space Use Case Study in RRI. Thank you very much for your kind introduction. I am Irie Naohiko, Working Group 1 Co-Chair and Senior Strategist, Control System Platform Division, Hitachi Limited. Last year at RRI, we have had a use case study of industrial data space, which I would like to share with you on this occasion. We will also be exploring the international trends and directions that we should be heading forward. First, this is the organization of RRI. I will be just skipping the top half of the slide, but please pay attention to the bottom of this slide. There are 3 working groups at RRI, and Working Group 1 is the Manufacturing Business Revolution through IoT Working Group, under which there are 4 action groups. And Action Group 4 is on the Industrial Data Collaboration for Engineering Transformation, led by Professor Kondo of the University of Tokyo. Under Action Group 4, there are 4 task forces. The first task force, as has been discussed in detail by previous speakers, are survey and evaluation of Catena X trends and other initiatives. And this task force also organized webinars to promote the penetration of this Catena X and other trends at Japan as well. And we are on Task Force 2, Consideration of Use Cases for Industrial Data Space. Task Force 3 is about the Future Technology Study for Engineering Transformation. And Task 4 is the one that is being launched this year. And TTCom's Mr. Sakaino lead this task force to promote the communication with domestic and international organizations. And use cases have been explored at Task Force 2, which I now would like to discuss. Before doing that, allow me to introduce the members that joined the discussion. Use case from the user company perspective, there are several participants. And there were also participants as a platform builder. We also do have persons with consulting perspective and digital X, Green X Digital Consortium. So altogether, 24 people joined this task force. Last year's International Symposium also touched upon this framework. Data space. We first discussed the common goal of this framework. And in trying to explore the common goal, we then also looked into the concerns that may arise by the use of such framework. We assessed these negative impact of the use of such framework before deciding on the common goal. So at the step 1, we first discussed the common goal of the framework. Then through the discussion, we have concluded that 2 major goals, one being setting common goals for industrial data collaboration to solve social issues. Having said that, because they're corporate stakeholders, it also needs to have certain business incentives to do so. And we extracted 5 elements of incentives, one being the circular economy, decarbonization, safety and security, and international collaboration, and society gentle to the people. These are the 5 areas of incentives. Productivity improvement and cost cutting can also be another aspect of incentives, and competitiveness of the products and its improvement, and also corporate value increase, followed by the corporate social responsibility, and 5th, new market creation. So solving social issues and increasing corporate value can be pursued concurrently or may be mutually conflicting. However, the key here is to make it compatible. Not only driving these 2 goals within a company, we also have to drive the incentives of end users, shareholders, industry, country, and international communities. And that was the gist of the discussion that we have had. And as a second step, we then also assess the concerns from a user perspective. There are 4 points of concern in total. At the center is the data space that needs to be managed and operated. Data holders and data providers' concerns have their own concerns, and there are concerns on the part of the users of such data. So there are different types of concerns depending on the position in this flowchart. Rulemaking or standardizations, authentication or tools, all these needs to be looked into, trying to minimize the concerns that may arise from the use of such framework. Use case scenarios have also been assessed. On the left is the list of scenarios submitted by the 24 members. In total, we have had 16 use case scenarios. As you can see, there are certain overlaps between different scenarios. That is why we grouped these scenarios into 4 groupings. On the right, you can see a matrix horizontally. This is quite similar to the first layer of IMX. Sustainability, resilience, and innovation are the horizontal axis. So this is more like a neutralization of negative impacts. And IMX, competitiveness, and innovation is something that we can seek to achieve after neutralizing the negative impact. And vertically, you can see the types of data that needs to be shared. Some of the data will be linked to the products that needs to be shared. Other types of data may also be related to corporate activities that needs to be circulated and shared. So that is the quadrants matrix over which we have laid out 4 groupings of use case scenarios. This is such a busy slide. And the summary is the 16 scenarios. Vertically, you can see 4 different groupings of the use case scenarios, as well as the overview of each scenario and the values that each scenario seeks to achieve, be it social or environmental value, or corporate value even. And then we identify the stakeholders who can drive these values. And we also clarified the data or information that needs to be shared to achieve each goal. I do not go into the detail of this table, so just let me share with you part of the table.
First, starting with use case number 1. This is ESG indicators relating to products that are used to identify this use case. There are multiple supply chain players, for example, CO2 emission, carbon footprint. Take that as an example. And eventually, product manufacturer will disclose this information to users, possibly to investors, as well as regulatory authorities. So this is the use case of disclosure of that information. By doing so, we'll be able to strive to achieve decarbonization society, and companies will be able to maintain the product competitiveness at the same time. Second example has to do with quality of product. It's a traceability scenario. Products are increasingly complex today, and there is a lot of relevant engineering information to be shared. The challenge today is product-related cyber attack that has become a major challenge. Vulnerability, a software bomb, that sort of information is to be shared. By doing so, eventually, very important airplane, social infrastructure-related products, we will be able to clearly identify vulnerabilities and manage them, and will be better deal with a possible incident when it breaks out. So safety, security, and resiliency would be the value that can be generated in both corporate as well as society sector. Thirdly, that is the resource sharing between companies. Companies, especially manufacturers, when they produce product, they have to consume resources. In this example, this has to do with logistics as well as energy consumption. Especially the question today is how you can procure green energies. How much energy is needed, how much you can share, that information can be transacted in data space. Companies may be able to increase its resilience and possibly reduce cost as well. This is the fourth example. This is about the circular economy. Of course, this has to do with sustainability. This is more about creating a new market. So it's not just limited to manufacturers. Arterial downstream companies can participate in this new economic zone. And there is diverse information necessary. What are the components that are used in the product? How you can decompose, how the products are used. That information has to be passed on from upstream players, eventually down to the players that recycle, reuse the products after use. By doing so, we'll be able to achieve circular economy and make new markets. So I've talked about 4 use cases, 4 examples here. But looking back, is it really possible That's the fundamental question that you might ask, especially if you look at the first use case, that is ISST information sharing. Badly passport, DPP could be good examples in this case. What we have to do will be identified, and we give a structure to that. Of course, these are relevant to data spaces. We have to look at participating companies. They need to provide functions, and we have to have trusted platform to support the companies. So there are three perspectives here. And we have summarized our challenges from these three perspectives. In relation to data space, we have to have international rules, we have to have international standards, and we have to have international connectivity and interoperability. And in terms of operation, each space will be operated independently, but we have to be able to federate them, and data model for transaction and sharing need to be developed. And going to the right, in the eyes of user companies, there are many things that they have to consider. They have in-house data. How can they organize internal data? I think this is a very serious problem to Japanese companies. So when data is to be disclosed, you have to have standardization. You have to make sure data is highly reliable. So it's the issue of data management. And they have to change the mindset before they are ready to participate in data spaces. And going down to bottom left, in order to participate in data space, trust will become indispensable. Would companies be allowed to data space? How can they prepare themselves to be able to participate in data space? And of course, trust should be part of that foundation. So these are some of the challenges we have been able to identify, and this is the result of our discussion last year. As you can see on the left-hand side, we have a report. In August, we issued this report. In relation to this, from the very beginning, METI has been involved in this process, and this May, we publicized the manufacturing white paper issued by METI, and they actually referred to this report. The common goals and use cases were actually referred to in METI's official report. Internally, domestically, badly passport will be the target. We have a new ecosystem, Uranos, that has been just launched. How we are going to deal with this internationally, how we can expand and increase use cases, I think that management has to be coordinated. And that discussion will be done within Keidanren. There will be a new committee started. And we, RRI members, myself and Sakaino-san, will participate in the committee. And we came up with this proposal. And October 15th, we are going to disclose this proposal document. As I said earlier, the topics that I discussed today are included in this proposal document. Industrial data space establishment. And along with that, we have to have trusted foundation, trusted platform in Japan are both important. And as Dr. Hahn, Professor Otto said, international interoperability is a critical issue. How we can promote this in private and public sector. How can we involve user companies? How can we make sure use cases that are engaging enough to private companies? So these are the challenges that we all discussed together. And as a result, we came up with this proposal paper. And this will be the basis for us to be able to build frameworks going forward. Now, this is my last slide. All of you who are here today, and especially those coming all the way from Germany. We would like to achieve international cooperation and how we can use that framework to achieve higher value. That's what I want to discuss with all of you today. Thank you.
ありがとうございました。それでは引き
Thank you very much, Mr. Irie. And now we'd like to begin the panel discussion. Professor Otto is joining us on remote online, and the panel is participated by Irie-san as well as Mr. Schneider. Thank you very much. Please come forward and join us, Dr. Schneider. Now, we have time until 1 o'clock, so why don't we start the panel discussion. Now, in advance to the panel today, we have prepared some materials, documents, and have already prepared some questions for the panel members. Also, we have received some questions from the participants. So we'd like to try to mix them together as we proceed. Now, moving on to the next slide. Rather, before we start, first of all, I have to introduce to you our panel members. From Fraunhofer ISST, we have Professor Otto with us. Thank you very much for joining. Also from Hitachi, WG1 co-chairperson, we have Dr. Irie. Also, we have a new member for the panel. We have Dr. Sebastian Schneider from DMG Mori. Later on, I'll ask him to introduce himself, and I'll be moderating. I'm Nakashima, RRI. Thank you very much. Now, first, Dr. Schneider, can you please very briefly introduce yourself?
Thank you very much for having me. My name is Sebastian Schneider. I'm since 15 years at DMG Mori in Germany, and therefore responsible for the R&D projects. And one very important project is Manufacturing X or Factory X, and I'm responsible for this project.
ありがとうございます。
Thank you very much. Now I'd like to move on to the panel discussion. We have 5 major topics to discuss in this panel, especially during session 1, we are discussing German and European activities. Therefore, number 1 and 2 on the slide is more for European or German activities. We would like to understand what is happening in more detail. The third question is about the situation in Japan. The fourth point being that not just Japan, Germany, but global activities. What should be our take? And lastly, we'll have a conclusion. So why don't I move on to the first question? And I would like to follow this in order. Now, Catena X, and this question goes to Dr. Schneider. And Catena X, in Catena X, automotive OEM showed strong leadership. And there is a typo in Japanese. It says strong, powerful leadership is a driving force. But what about the situation in Factory X? Are there any very strong drivers, leadership companies, or is it moving ahead in another format? That would be my first question to you, Dr. Schneider.
We have 46 companies involved. There are the 2 main important software companies, Siemens and SAP. Then we have 2 machine tool builders, Trumpf and DMG Mori. And we have a lot of, let's say, other participants like suppliers of us. EFM is a sensor specialist, Festo, for example, and others. And also we have then some smaller software companies and also some research companies involved. And maybe to add, so all of them have not only one role, but maybe further roles. So some of them have also the role as a let's say, company or factory operator. So, for example, Siemens has also some machines from us, and there we can also implement our new products.
ありがとうございます。
Thank you very much. So, for the entire industry, the concept of manufacturing is changing, and that's what Factory X is working on. That's my understanding of what it is. Another question to Dr. Schneider. Earlier, in the Hansen slide, he talked about use case for Factory X, and there are 11 use cases that he had presented. And you can, perhaps rather than working on all 11 simultaneously, maybe there are some more important use cases, priorities. Which ones of all of the 11 are the important or high priority use cases? That's the first question in my second part of the question. And as you engage, as you prioritize those use cases, how will manufacturing practices change in the future? Those are my questions.
We have these 11 use cases. We have also the categories, and I like the idea that also you showed before. There's also the categories in Japan, that they are quite similar to that, and maybe to do it in or to use these categories. So first topic, and I think that was also the topic which Tomas and also Dr. Irie showed, the topic of sustainability and energy management. So of course we have the topic of product carbon footprint. That's also relevant for us. But the other way around, we as a machine tool builder have also the responsibility regarding energy management. So the energy taking some measures to reduce the energy consumption of the machine tools. And there we have also possibilities with data exchange to reduce the energy consumption. Mm-hmm. And so this is also quite important. And I think you asked how this will change the manufacturing process. So with exchanging data, it's possible to reduce maybe also some energy consumption, and also to adapt. You showed before this, let's say, the resources and the adoption of the resources. There you can also adapt then the energy consumption, for example, and this is also possible with data exchange. Mm-hmm. So that's maybe one topic. Second very important topic is a topic regarding competitiveness of our companies, of our customers. So when we want to improve our machines must run more hours during the year. And therefore, it's necessary that we have an autonomous operation as a service. And so that's one of the use cases which is very crucial for us to provide measures how to, let's say, make the machines run more hours a year, and that our customers can, let's say, produce more and earn more money with it. That's second topic. Then third topic, also what you showed before a little bit, like traceability, is also very important. Actually, a lot of our customers are in aerospace, and we are also involved in Aerospace X, because there we can also then, let's say, develop the use cases for them. And one very important topic in aerospace is the topic of traceability. So in Catena X, there's always the example traceability of the parts, and if you have then a wrong part, then how to get all the affected cars. And also in aerospace, same topic. So if there is any error, how to make sure what was the reason for it and how was the process conditions. And therefore, traceability is a very critical part and or very critical topic. And that's also one of the, let's say, use cases which is very, very relevant for us. Further topic is then maybe also condition monitoring-led service. That's also from, let's say, the amount of money and also participants involved, one of the biggest use cases, because at the moment it's like this, that we can, of course, have the overview on the machine, how is the status of any kind of machine. But with data exchange, we can improve the service much more, and we can then also sell the customer much more new service models to increase the availability of the machine.
ありがとうございます。
Thank you. We have received a couple of questions from the venue participants about a factory use case, which I would now like to ask the participants. I think that it was related to the use case presented by Dr. Hahn, DPPs within the 11 use cases. When exploring use cases, before deciding on an appropriate approach, I assume that it is a process that is shared across the industry. But do you have any specific guidelines or documentation to guide the information sharing across the industry?
At the moment, we don't have the guideline. We are developing it right now regarding the data exchange. So that's at the moment in development. But of course, at the end, there will be some guideline coming out of that.
多分、DPP を
DPP implementation or the mechanism of DPP will be used, and exactly how it is to be used is something that Japanese counterparts are also highly interested in. So it will be wonderful if we can share that process of formulation of guideline as well. Now, let's move on to the next question. So we now have touched upon the use cases. In exploring use cases, I believe that data spaces needs to be joined by a large number of companies, meaning that companies must be interested in and incentivized to join the data space. How can we drive the wider support base of corporate participants? What initiatives are being driven in Europe? What efforts are being made? I would like to ask Sebastian, and also I would also like to ask Dr. Otto as well.
So within the project Factory X, we call it customer sound sports. So that's the possibility that we show all our customers how is the actual status, how are the use cases, and what could be the benefit for them. And that's what we show them within these customer soundboards. And then, of course, later on, there is also the possibility that they can participate then within the project, let's say, as application companies. So this is the first step of integration of customers. Second step of integration, I think you saw it in the slides at the beginning from Hahn-san. There was this, let's say, the transfer and scale MX. So we are starting a big project called Scale MX, which is focusing on the transfer to SMEs, and then that's the next step to how to transfer all the new products, all the new ideas in the, let's say, in all the companies, in all the SMEs.
はい、ありがとうございます。Otto 先生いかがでしょうか。
Dr. Otto, on question number 3, do you have any interventions?
Yeah, that's of course a very important question that is also very close to my heart. Let me give three points, or let me answer with 3 points to this question. First of all, we are talking about ecosystems, and in ecosystems we need to acknowledge the fact that network effects apply. That means the more participants we have for a data space and a data ecosystem, the greater is the value for all the individual participants. So therefore we must have an interest to scale as much as possible. Second thing, in order to reach that, what we need to do is to lower the entry barriers for every individual participant as much as we can. And that is also something that we have learned in Catena X to, as I said, make the onboarding process as quick as possible and as easy as possible. So it should be no burden for a company to join a data space. And also, we must, let's say, offer directly from joining first value, business value for the participants. And that is something which I believe will come, for example, through very basic data services, for example, around master data, but also I think around things that everybody needs to address, for example, DPP. The third aspect that I would like to stress to this question goes back to what Irie-san also said, which is the internal readiness of companies. So the internal data management capability of the organizations, of the companies, must improve in order to be ready to be connected to a data space. To be honest, I think this is the biggest challenge. Because I have been, let's say, working on this field for 25 years. We made great progress, I should say, but there is still many things to be done, I must say. So 3 things: network effects on ecosystem level, direct business benefit, low entry barriers for every single participant, and number 3, increasing maturity of internal data management capabilities.
はい、ありがとうございます。非常に本質
Thank you very much. That is a very substantive, important points. Next slide, please. Here, we'd like to discuss the readiness, challenges and solutions of companies in Europe. We also have received some questions related to readiness. Let's go to question number 3. On the top half of the slide, Japanese companies do not seem to be as ready as their European companies to invest in industrial data exchange. For companies to promote sharing, how can we drive wider participation? What are the motivations on the part of European companies to join this movement? This question is again to the 2 speakers who have answered to the previous questions. Can you give us any hints?
Yes, of course. So maybe the first thing is, I think, the lessons learned from the previous projects was that before we always developed the solutions for ourselves, and now that's the answer in Factory X and Manufacturing X. We need, let's say, a strong collaboration of all companies. So as Tomas mentioned before, we cannot do that by ourselves. And I think that's one of the most important things and lessons learned. And I think that's mostly the most important thing. And then maybe also what we also need to do, I think we need easy solutions at the beginning. You see that also in Catena X. I think the easy solutions which all of the users are, all of the companies are using, that's what we should start with, and then we can maybe also integrate them later on more complex solutions.
ありがとうございます。
Thank you. Dr. Otto?
Yeah, I think there are 2 major drivers. And once more, it's not an end in itself. So we do not engage in data sharing because we have nothing else to do. But it's, let's say, something that helps companies to, let's say, increase their competitive position, right? So be more competitive and also sustain their competitive advantage. As Sebastian also said, in many cases, companies realize that it's better to team up with others because, for example, also again in Catena, they realized that it was just too expensive if everybody would try to implement a data sharing platform by themselves. And they would never have, let's say, achieved the adoption in the value chain that would have been needed to be successful. So sharing a burden together addressing a challenge is one of the key drivers. The other fundamental driver is innovation. For example, there is a very interesting ecosystem called GDSO. It's basically around the tire industry. So basically, well, tires for cars and let's say large excavators and so on and so forth, where also European, but also many Japanese companies are involved. And they teamed up in order to, well, seize the innovation potential that comes out of, let's say, sharing data across the entire life cycle of a tire, right? So innovation is a key driver for teaming up in data ecosystems. Of course, it's always easier to start with the cost side, but I think the biggest potential is as we go, then more towards, let's say, innovative business scenarios. And we touched upon another very important one, which is circular economy. And I personally think that this is, let's say, a direction that in particular European, but I guess also Japanese should go because, well, that's a huge innovation potential for us to seize.
はい、ありがとうございます。ここの、スライド。
Thank you very much. On this slide, there is one more question. The lower half of the slide has a question on data space. We tend to talk about the system when we talk about data space. As has been pointed out today, the perspective of users using companies, are they ready to use and participate in data space? That is a major challenge. For example, in Europe, Catena X has already started now using companies, user companies. Were they ready? It's very hard to express to what extent companies were ready, because there are many companies, including SMEs. Were they prepared enough to be able to use data spaces fully, or do they have to work on that more to be able to use fully the data spaces? So this question is also to Sebastian as well as Dr. Otto, please.
So first thing was, I think the answer was already in the question before. The question, let's say, that we analyzed and said that we can only make it together. Second topic is, I addressed it a little bit before, let's say the kind of use cases. So we had a lot of applications before as digital products, which were, let's say, not so directly related to machine tools and the manufacturing process. And that's why we had a lot of effort for creating this kind of solutions, but the benefit was not that high. And I think that's also something, that's what I mentioned before, when we need use cases which a lot of customers can easily need and can easily use, and I think which are more related to the manufacturing process itself. So that's why I said condition monitoring-led services. We have a lot of machines with a lot of sensors inside which we can use, and that's why we, for example, use this as an example or use this as a use case to take their benefit for our customers.
ありがとうございます。オット先生いかがでしょう。
Thank you. Dr. Otto, please.
Yeah, I think it is what we also discussed earlier, very important that companies, let's say, continue to improve their data management capability in the company. So if we talk about that data is a strategic resource, then we also manage data as such. And once more, we have, let's say, improved a lot over the last 20, 25 years, but I think there is still room for improvement. To give you a very concrete example, I think one of the key capabilities within a company is a comprehensive data catalog, which basically is an inventory of all the data resources that I have in a company, which comprises, let's say, technical aspects like, okay, where's the data source and through which API is it accessible and so on and so forth. It also has, let's say, a business aspect. Well, who's responsible? Who's the business owner for this kind of data sources? And of course, a legal aspect. Under which conditions am I allowed to share this data with whom? And so on and so forth. And this capability needs to be established in all companies in order to be ready to efficiently participate in a data space. If I don't have that, I will have no fun in participating in data ecosystems. So this is really critical. A last point on this. This is not only something that comes along with data spaces. Data spaces and data ecosystems are just a trigger to improve. As we learned from Sebastian Schneider and also Thomas Hahn and other speakers, there are so many challenges that a company has to address and so many opportunities to seize, which simply require, let's say, the further development and maturing of the data management capability. So you have to do it anyway. But let's say, pay attention to that and make yourself ready. Shortly do the homework, so to say, in order to be a part of a data ecosystem.
ありがとうございます。そうすると
Thank you very much. So those are the requirements. Needs are widely recognized in Europe, I believe. So have you already achieved high level of that recognition? Do you think many companies in Europe, do they have to do more to achieve that level required? Dr. Otto, please.
Yes, a couple of years ago, we conducted a survey among the German companies. And this survey was thankfully supported by the Federal Ministry for Economic Affairs. And that showed that on a maturity model, which consists of maturity levels from 0, which is the lowest level, to 5, which is the highest level, that 80%, 80, assess themselves on the 2 lowest levels. And that was, of course, eye-opening. I think this has to be put into context. This study was conducted 4 years ago or even 5, so the situation has improved. And in this 80%, the majority of the companies were really small and micro companies. However, those are important because in our value chains, if I go to the second or third tier of the value chain, I very quickly end up with very small companies who, for example, do a certain, metal sheet processing for, I don't know, a car engine or something. So we need to address these small companies and make them ready. That must be one of the paramount actions in order to make data ecosystems successful. And what Sebastian Schneider said, the scaling initiative in Manufacturing X will support that very much. We also have, other, initiatives already established, like Transfer X, for example, which basically educates and supports individual companies in increasing their readiness. But this must be our top priority, and I'm sure that the situation in other, highly developed economies is similar, as I just referred to as in Germany. But this is something that we need to do. And perhaps a last comment, this is also an opportunity, because if we play it right, then data ecosystem could just, offer some sort of outsourcing opportunity for small companies for their data management. So they can just do their data management, in fact, in the end, through a data ecosystem and not have to care about it on their own, I think. And because that is a big opportunity, because if we go from one to the next and try to do the integration, that will just take too long. I think we need to offer new cool data management services to reach to create the broad adoption and reach out to all these micro companies that are out there. Yeah.
はい、ありがとうございます。とってもよく状況が分かりました。
Thank you very much. We very well understand the situation in Germany. Let's move on to the next question. This is about Japan. So I'd like to ask this question to Mr. Irie. We have Uranus system started. So maybe you can give us the current overview of what is taking place in Japan, the awareness of companies, what are the areas that need attention, and you talked about proposal documents prepared by Keidanren. So what are some of the expected initiatives coming up in Japan? So first, to talk about the internal situation, it's not that I understand everything. Uranus ecosystem, it's very hard for me to personally talk about this system. As I said in my presentation, it is similar to the Badley passport amongst automotive industries. They are working on this new project. So this is one use case emerging. How can we expand this to international cooperation? How can we increase the number of use cases? That I think is the major challenges that we have in Japan today. Having said that, in Europe, especially in Germany, the initiatives taken there are very widely spreading. The rules has been made, standardization is progressing, platform has been laid. But internally, in Japan, although this is my personal observation, we have to have clear-cut use cases first to encourage companies to start moving toward data exchange. So what are some of the use cases that we can make in Japan? We have to involve relevant ministries and Keidanren and specific companies. So we have to have sort of consensus as to how we can proceed within Japan. So in that sense, this proposal coming from Keidanren this week is a good opportunity.
And in Keidanren's proposal, more than 10 companies have participated and in us putting together the proposal. So as we discuss the proposal, what are the possible use cases, what are the challenges, those are the discussion taking place already. We would like to use this discussion and argument as a basis for us to move towards international collaboration and other expanded activities. Thank you very much. Now we are running out of time, so why don't we move ahead? The fourth point in question. So far we've talked about Japan and Germany, but we would like to move towards global collaboration as well. Now, this is the question to Dr. Schneider and Professor Otto once again for your views. Now, about International Manufacturing X, or called IMX, at least that's what it says on the slide, for a global manufacturing data space expansion and to ensure interoperability, efforts have begun. That's how I understand IMX. Now, at the same time, for different regions, business practices, corporate readiness, we've already talked about readiness, or the concept of data space may vary depending on the regions or the areas in the world. So in the future, global interoperability achievement, what should be the perspectives we should have in terms of variabilities as we move towards this way? I would like to have your view on this.
The study from Keidanren was very good, and when you see that the use cases, they are quite similar, as Dr. Irie already mentioned, so they are quite similar also to our use cases. And of course, there are then maybe dependent on the region and dependent on the, let's say, on the branches, maybe some variances of the use cases, but the general idea is quite similar. And what we also do is that within International Manufacturing X, we are looking that we, let's say, get an overview about all the different projects and activities going on worldwide, and to coordinate them a little bit, to adjust the different views, and to see if when there are, for example, when there is one activity going on with product carbon footprint, to adjust the different activities, first of all in Germany, and then later on maybe also worldwide, that we have then a common understanding of how product carbon footprint should look like, or any kind of other topic.
ありがとうございます。オット先生いかがでしょうか。
Yeah.
Thank you, Professor Otto.
Yeah, I think as mentioned, many of, let's say, the use cases are global ones, so we need to address them together. And what I always find helpful is to, let's say, structure the task into, let's say, different layers, which is also why I mentioned earlier on this interoperability framework, which identifies 4 different layers, like the legal layer, the organizational one, the semantic one, and technical one. And I think we have, let's say, lots of experiences in working together on technical and semantic standardization, be it, for example, for very generic, let's say, aspects on ISO level, but also on W3C level. But also, let's say, industry standardization. OPC was mentioned earlier on, which we can basically, rely on and draw from. But of course, there will be other things that we need to, map somehow, or analyze first, let's say, compatibility. I think, in particular, when it comes to the legal frameworks, like always, according to the Pareto law, there will be 80% which somehow match and others that don't. And then we need to basically make sure how to achieve interoperability also on these grounds. But I'm sure that this will be possible because, once more, we share the same challenges. And therefore, I think data sharing on a cross-border basis is of interest for all players in the field. And these kind of, let's say, interoperability frameworks would allow us to structure the task and to cut, let's say, the task into manageable pieces. And that is something which I like. And I think we have also made, let's say, in the collaboration between Japan and Europe, great progress over the last 10 years and achieved a lot. So I'm convinced that we will also be able to address this issue.
Thank you very much. ありがとうございます。もう一つ。
Thank you very much. One more question, and this goes to Dr. Irie. This is question 2. RRI is also participating in IMX. What are the views you have in terms of establishing the global interoperability? Well, IMX, we have been invited and we are participating as RRI, but not just RRI, but there are various other organizations, including government agencies, that we collaborate with as we engage with IMX. Now, one thing. Right now in Japan, data space is being structured, and how are we going to make this interoperable globally? That's really an important discussion point. As Dr. Otto showed us his slide earlier, various integration levels to nested format, the data space variability should be recognized, and with the recognition, we need to ensure interoperability. That is the type of discussion that is truly needed, and that's the perspective or the view we have as we participate in IMX. Another point, as Sebastian said, globally, common use case needs to be set up. That will be important. For example, carbon footprint or the DPP that Europe is leading right now. Global collaboration is truly needed in order for that to be successful. Now, for common use case consensus achievement, each individual players will have to work for each individual regions organization. And I have a lot of expectation in IMX to make this move forward. Thank you very much. We are running out of time. We have received many questions, but we will not have time to answer all the questions. But in one way or the other, to all the questions that we have received, we would like to be able to receive comments from the panel members and would like to share their answers in the end. Lastly, the last question. The audience we have today who are here on the floor or those of you who are joining us online, quite a large number of those participants are from machine industries or manufacturing industries. Now, the panel members, to those audience, the industry data collaboration, for that perspective, what are the actions you would like to invite the participants to take? This is a question to all three of you. First, Dr. Schneider, could you please respond? What actions do you call appeal to your audience?
In the activities we saw before, and then maybe also define your own benefits, your own use cases, and then integrate it in your daily business.
ありがとうございます。じゃあ、次。
Thank you. Then Dr. Otto, please.
Yeah, I like this question very much because I think we should embrace more the logic of the software industry, of the platform and the app economy. We must understand the fundamental logic, how this works, in order to be successful, well, in this field. And if I may, sometimes I still have the impression that software and data is still considered, let's say, you know, the black sheep, not sure whether that exists in Japanese as well, of, let's say, well, the little sister of mechanical and electrical engineering, and this must change. So we need to embrace, let's say, the value creation potential of software and data in its full right, and not just as a side product of mechanical and electrical engineering.
ありがとうございます。では最後、入江さんの方から一言をね。
Dr. Irie, please.
なかなかその
Situation at home needs to be driven. So, those stakeholders in the manufacturing industry, please do not consider this as a risk factor or a cost center. Please try to use it as much as possible for your benefit. Within RRI, we also have this discussion. At the nascent phase of Internet, we had a similar situation. After the rise of the Internet, business convenience has exponentially expanded. So data space needs to be globally shared to create wider set of opportunities for everyone. So that should be the source of aspirations to drive this initiative. And that is why I want to ask for your wider participation. Thank you very much, gentlemen. So it was a very short session of 2 hours, but it was full of action and information. And this concludes the panel discussion. Dr. Otto, Dr. Schneider, and Dr. Irie, thank you very much for your contributions. This concludes session 1. A warm round of applause is in order for the discussants. My special thanks also goes to everyone who attended both in person and online. I will now inform you of the schedule for the rest of the session. We'll be having a 1-hour lunch break. From 2 p.m., we'll be starting the session 2. In session 2, we will introduce case studies of common issues in Japan, Germany, Europe, and the United States. We will share with you all those analytical cases and discuss issues in digital policies and issues that need to be resolved through international collaboration. So I hope you will come back after the lunch break. If you are to exit from this room for your lunch break, please return the simultaneous interpretation receiver. And those of you who will be coming back can keep it on your seat, but those of you who are not coming back, please return it to the reception desk. With this, session 1 is closed.
ライドのめくるやつ。
They want to change the names.
失礼しました。テーブルが傾いてるんだ。
ご来場の皆様、ありがとうございます。あと1分ほど。
We'll start the afternoon session in about 1 minute, so please come back to your seats.
So それではお時間となります。
Thank you very much. We will begin session 2. But before we begin the session, we have one request. As was the case of session 1, if you have any questions, please open the Q&A site and slides from the link in the YouTube description. And give us your affiliation and your name in the name field to enter your question. Now let's move to the session. In session 2, we'll have a panel discussion. First, let me introduce to you the panel members. Seated next to me from the Siemens AG in Germany, we have Mr. Thomas Hahn. And then on the other side, from Purdue University, we have Professor Athinarayanan. And from Japan, we have Professor Kimura, Professor Emeritus at the University of Tokyo. And I am Nonaka from Hitachi, and I'll be serving as the moderator. First of all, let us begin by setting our topic. Now, what is the motivation for the panel? The EU, United States, and Japan, we had discussion for the past 6 months, and that's what I'd like to report to you. As the slide shows, and almost every day, the topic of planetary boundaries have been a hot issue, and during the past year, efforts have been made around the world to make human society more efficient through digitalization. Now, in the post-COVID-19 era, rather than enjoying the benefit of this, rather geopolitical risks have become more severe, and the human production activities piled up its problems. We call this a polycrisis, and together with environmental disasters and others. Now, the advantage of digitalization of Industry 4.0 is it really penetrating and contributing to the realization of a sustainable society? That's really the question, which is the foundation of our discussion. And in order to discuss this topic, as you find on the slide, from Japan, US, and EU, we have tri-regional joint project. And this is an international discussion team that's been organized from Japan, myself, and Dr. Kimura, and 2 others. From the United States, we have Dr. Athinarayanan from Purdue, SSBCO, 3 carpenters, and from Mr. Dyke and others. And we have had 4 meetings in the past. And in next spring in Hanover Besse, we would like to publish our discussion paper. Today, we would like to discuss these 4 points based on discussions we've already had in the past. First, we'll discuss the current activities to achieve industrial sustainability in each region using real data. Then we will discuss labor productivity, trade openness, and incentiveness, and this will be the basis of production. Next, jobs will be the topic. New jobs, lost jobs, the so-called gig work, and workforce strategies will be the topic in this discussion. Lastly, based on the above-mentioned 3 topics, what would be the policies and concepts for automation of work and digitalization, sharing and utilization of skills and know-hows globally? First, in session 1, we will discuss current activities for industrial sustainability in each region. And in this session, Japan, EU, and United States. We would like to hear industry-specific efforts and activities from each of these regions from our panel members. First, from the United States, we'd like to hear from Dr. Athena Rayanan about the activities in the United States.
Thank you, Professor Nanaka. Thanks for the opportunity for engaging Purdue University, SESME, and also the U.S. Department of Energy on this very exciting project. So I'd like to talk on this slide. We have 3 slides, and so I'd like to start by saying that there are 3 pillars to all sustainable development initiatives within the United States. They call it the triple bottom line, if you have not heard it before. That is the term that's used in all federal agencies and also in the private industry. So this is a balance between the economics, where we talk about the product and the process, the environmental impact, which is the planet, and the social responsibility and equity, which is the people. So the goal is, how can we balance the economics, the environment, and the social responsibility and equity in developing, in creating sustainable development in the US. So in alignment with this, I prepared this slide so I can share with you some of the initiatives that are going on in the US currently. The first is called the Sustainable Development Goal. Many of you probably are aware of this. I see many colleagues here from Germany. So this is, this is a global initiative, but US is contributing to it to support the 17 Sustainable Development Goals that addresses climate action, clean energy, responsible consumption, aligning economic growth with sustainability and equitable well-being. On item number 2, which is the U.S. National Climate Strategy, this is the goal to get to net zero by 2050. This is part of the federal sustainability plan that was signed into order by President Biden in December of 2021 in his effort to rejoin the Paris Climate Accord. So this strategy aims to achieve net zero greenhouse gas emissions by 2050, focusing on renewable energy, decarbonization of the economy, and transitioning away from fossil fuels. And there were several legislative actions that came as a result of this, and one being the Inflation Reduction Act, which is the largest act that was passed, and also the CHIPS and Science Act of 2022. Combined, both of these are designed to help us achieve the goal of net zero by 2050. Third, I'm going to talk about the America's climate resilience and adaptation efforts. So this is both a government and a private sector initiative investing in climate resilient infrastructure to protect operations and assets from extreme weather and climate impacts. As you probably know, US, depending on which sections of the US you're in, they are very prone to extreme weather conditions, and many of these are due to the climate change. Next, I'm going to talk about the circular economy. This is a strategy where we call that the 3 R's, which is the reduction, reuse, and recycling of materials to minimize waste, optimize resource use, and reduce the environmental footprint. And I'm going to, next is the justice, oops, okay. All right. Yes, first slide, please. Yeah. So the next one is the Justice 40 initiative to ensure that 40% of all benefits from federal investment in clean energy and climate action go to disadvantaged communities who are disproportionately impacted by climate change and environmental hazards. Because as you probably see in the United States, there are certain communities that are impacted more than the others. We can go to the next slide. Thank you, Dr. Nanaka. So in this slide, in the first slide, I was mentioning most of the federally funded programs that were that are focused on sustainability, but there has been a paradigm shift on the definition of what what competitiveness means for publicly traded companies in the United States. Particularly, we are living in a free market economy, and how are the private industries engaging in the sustainability action that was articulated earlier. So we see more and more on the resource efficiency and waste reduction, we see more and more industries are using digital and smart technologies in designing their processes and products so that they can minimize waste at each stage of the life cycle, from manufacturing, consumption, disposable, and recycling. An example of that is Caterpillar company. And next one is the regulation in CSR. So, and I'll explain what is CSR. That is the corporate social responsibility. So in the US, besides compliance to EPA regulations, EPA is the Environmental Protection Act, companies are voluntarily integrating social and environmental strategies into their business models. And the third is the climate risk disclosures. This is something fairly new, and this is enforced by the Securities and Exchange Commission, also known as the SEC, that requires publicly traded companies to report on greenhouse gas emissions, among other things, across two categories. One is the greenhouse gas emission protocol scope number 1, which is what is the amount of direct emissions from sources owned or controlled by that organization. Scope number 2 is indirect emissions from purchased energy. And scope number 3 did not pass in Congress, so that was not adopted. So if you're wondering what is scope number 3, that has to do with the greenhouse gas emissions across the entire value chain. And examples of companies that are practicing this, well, I shouldn't say examples of companies practicing this, they are required to practice it, companies like Google and Microsoft. So aligning with this, we see that many industries in the US are hiring chief sustainability officers so that they can lead these sustainability efforts and ensure accountability within the organizations. So the government programs, we have talked about this, but very quickly, DOE is the largest driver of many of the sustainability efforts, the clean energy transition, industrial decarbonization, carbon capture and storage, hydrogen roadmap. So I should say that this is a green hydrogen roadmap that is being created more in the R&D phase, and the circular economy. And I would like to also highlight a state-level initiative, a state government level initiative, where here we see California is committed to achieving carbon neutrality by 2045, which is even quicker than what the US is trying to get to by 2050. So they also have something known as a cap and trade program, where they set cap on total greenhouse gas emissions. So every industry is capped on how much greenhouse gas emission they can emit. And also it allows companies to trade on emission permits. Next, please. Okay. So this is a slide on what does the industrial sector looks like in the US. So to give you some perspective of the US industrial sector, okay, so the industrial sector accounts for 32% of the nation's energy usage. And they emit about 28 to 30% CO2 emissions on an annual basis, which is quite large. And the anticipated industrial sector energy demand by 2050 is a growth of about 30%, which equates to 15% extra CO2 emissions, or 15% increase in CO2 emissions. So that is the risk of not doing anything, right? So how do we create a US manufacturing ecosystem that is competitive, that not only thinks about the economics, but also is cognizant of the sustainability efforts? So this slide basically talks about the partnership that the US government and the private industries working with academia, trying to leverage the Manufacturing USA Institutes and the NIST MEP. NIST stands for National Institute of Standards and Technology, working together with the US government and academic institutions to address the competitiveness of US industries. So the Manufacturing USA Institute, AKA also known as, similar to the Fraunhofer Institutes in Germany, we have a network of 17 institutes developed with funding from the US Department of Defense, US Department of Energy, and US Department of Commerce. Their focus is to create partnerships between academia, government, and industry to build new manufacturing capabilities and technologies through research that can be transferred to industries. So that is the primary mission and goal of the Manufacturing USA Institute. Now on the right, you see the Manufacturing Extension Partnership. So this has been around even before the Manufacturing USA Institute. So this comes under the National Institute of Standards and Technology, which is NIST. And what they do is they provide tools and resources to small and medium-sized manufacturers in US to improve productivity and operations. Now, the focus is on small and medium because 75% of all manufacturing industries in the US are small and medium, and they generate about 50% of all produced and manufactured goods in the United States. So that is a group that they did not want to be forgotten. So here are some key highlights on their impact. So in 2022, the Manufacturing USA Institute spent about $416 million in R&D projects, leveraging $109 million from federal funding and $307 million from private sources. So this gets developed into a technology that then gets transferred by MEP to the industries. So if you see the life cycle of what happens in US manufacturing, where the technology development happens in Manufacturing USA Institute, the technology transfer happens between the MEPs and the Manufacturing USA Institute and goes into production.
ありがとうございます。足ナラヤン先生。
Thank you so much, Dr. Asnarayan. I have a short question that I want to ask now. In your presentation, you talked about U.S. competitiveness. You, I think, referred to this word several times. So in terms of the scope of your presentation today, how do you define competitiveness in this presentation? It's not just technology. There is also an aspect of technology transfer, human resource development, and also regulations and standard. So in what aspects U.S. government and private sector invest more in order to maintain U.S. competitiveness?
Thank you for the question. That's a great question. So I had to look into this, and to answer that question, I had to go look up a report that was presented to the White House in 2022 after President Biden signed the U.S. Sustainability Plan. So this is a report that was prepared by several agencies in the U.S. that describe what it means by U.S. competitiveness in the manufacturing industry, just focused on manufacturing industry. So there are 4 pillars that defines the U.S. competitiveness. First is innovation and technology leadership. So the ability to drive and adopt advanced technologies such as AI, clean energy, and advanced manufacturing that enhances productivity and economic growth. So that is one of the pillars. The second pillar is how do we create a skilled workforce so that we can sustain our manufacturing industries into the future. So how do we develop a workforce with the skills required for emerging industries, including the existing industries, supported by education, skilling, and training initiatives. Third pillar is sustainability and energy efficiency, aligning economic activities with environmental sustainability and social goals to meet global standards and secure long-term competitiveness. Fourth, and last but not least, how do we strengthen the supply chain resilience? So by advancing domestic manufacturing, so I have to underscore the word domestic manufacturing, and this is particularly true after the pandemic. So by advancing domestic manufacturing capabilities, we are trying to improve the supply chain resilience, so we are self-dependent on our own success and less dependent on, on the global supply chain, so that we can enhance both the economic and also the national security.
ありがとうございます。おっしゃっていただいた4つの柱は非常に
Thank you. Those 4 pillars, I think we've had similar discussion in Europe and Japan as well. So in this panel discussion as well, we can discuss what is common and also what is dissimilar, what is different. Now, next, I want to look at Japan's activities. I'd like to invite Professor Kimura to present, please. Thank you for that introduction. On a national level, Science and Technology Development Plan and Industrial Sustainability and Well-being, I'd like to cover these topics in Japan. Starting with the left-hand side, it's a basic science and technology policy, which is discussed by Council for Science and Technology and Innovation. And every 5 years, basic plan is reviewed. Starting with Society 5.0, we came up with a sustainable and resilient society as a goal. Now going to the right-hand side, specific development programs. There are several. So left-hand side. In order to achieve long-term target, we have Moonshot Research and Development Program, and also cross-ministerial SIP, Strategic Innovation Program, to achieve sustainability goal. Specific examples of SIP, I have 2 examples, which I'd like to talk about later on. Now, to the right, we have specific plans. METI and Ministry of the Environment and Cabinet Office came up with basic plans, and based on that, industrial associations engage in various activities for social implementation. Next slide, please. Left-hand side. These are the activities of METI. As I said, we want to achieve carbon neutrality in 2050. So METI is encouraging multiple teams to be engaged in this activity to achieve this. One of the examples is GX League. And JTAS, Japan Electronics and Information Technology Industries Association, came up with the Green by Digital Consortium to set the CO2 visualization framework. On to the right, NATO, New Energy and Industrial Technology Development Organization, and JST, Japan Science and Technology Agency, are working on sustainability and social well-being. They are actually have multiple funding programs. Next. Relevant research and development organizations and Ministry, National Research Institute, and industrial associations came up with different programs of different scales to promote research and development as well as social implementation. Topics listed here are very similar to other countries. The way we bring them into implementation may be different. On to the right-hand side, we have Science Council of Japan. They have academic perspective to make a proposal for sustainability and well-being. There are many reports issued by this council. Lastly, as I mentioned, 2 representative programs of SIP. The SIP projects, industry, government, and academia all participate. So they are recognized as center of excellence. They actually cover all the processes immediately before social implementation. And they have hundreds of millions of dollars as budget. We're expecting to see substantial outcome. The project that I indicated here use information exchange platform focusing on plastics. They would like to establish closed cycle for complete recycling. Plastic are the source of multiple problems in society. So this program intends to solve social issues completely. Next, please. Next project that I want to introduce are also aims to solve multiple social issues using CPS, cyber physics space, to focus on human-machine collaboration. Robotics concept is utilized here to achieve higher level of diversity and trying to create inclusive society. Sorry, that's an overview level, but I've covered some of the examples here. Thank you very much. I have a question. Now, in Japan, we have Society 5.0 as a leading program. Now, as we were discussing, planetary boundary and well-being, there are multiple aspects of efforts that are needed. So when you look at planetary boundary, and the other side is well-being, how they are related to each other. Are there any efforts to bundle them together to achieve a balance between these two? Do you have specific examples? It's a difficult question to answer. In Japan, overall, we have planetary boundary perspective and well-being perspective. They can coexist together. They can be mutually positive to achieve even higher synergy. In other words, diverse labor can help create an inclusive society. We'll be able to better utilize labor that is available. And this is very important to achieve sustainability in society as well. But as a matter of fact, planetary boundary and well-being, there are different organizations, and they are now trying to collaborate, but not to the extent that is satisfactory yet. So Science and Technology Innovation Council, or JST, are discussing on set of principles. So the SIP cross-discipline project promoted under that principles. So what I want to mention is it is important to have interaction between both sides, and we would like to see that efforts to be enhanced in the future.
Enhancing well-being and bring the effect into the planetary boundary aspects for improvement. That's not just for Japan, but one of the discussions taking place in the United States or in European countries. So that's the point we'd like to continue to discuss in the panel. Dr. Hahn, using the next slide, could you please introduce the activities in Europe and Germany?
I just thought I came here in the room and nothing, but then I recognized, thanks to your hint, that the mic was not on. But let's extend a little bit and putting also a different flavor, because, as you know, we have also agreed upfront that we are touching different flavors, how is this done in the different regions of the world. And I would extend a little bit what we have discussed in the morning. Regarding the targets, I think you mentioned this before, we have some kind of joint target what we have to achieve. Interesting is to learn from each other how we implement this. And this is, let's say, what we are discussing here in the panel regarding the 3 to 4 other topic discussion rounds which we have. So, but let's highlight again, and I reuse this slide because we have in Europe or in Germany the Green Deal Act where we are looking also CO2 emission We have also, when you're speaking about resilience, initiatives around compute power, HPC systems, towards AI, and to use these capabilities towards AI. And we have, as you know, in some programs set it up, and I would only to highlight this, what are the concrete activities which we are doing jointly together, and that's the reason why you reused this slide here. And you see in the bottom, doing this together, it's, you know, as said before, it's not only an activity which we can drive from one country, it's our joint goal which was to achieve. And you know, the first topic is always regarding resilience. And resilience, to give you an flavor, is not only supply chain, is not only to have, let's say, the capabilities like you mentioned with factories or know-how in the country, is also about how we are get the right amount of skilled workers to do also the future stuff, which are also trained in the area of you know, sustainability targets, but nevertheless we will touch later on this. So that's one topic, and as you see, that's the reason why I have a blue box around the resilience topic to use this. Second is regarding sustainability, obvious. We have also CO2 emission targets which we have to fulfill. We have to look how we get the right process, and Raghu mentioned correctly, when you're looking at the CO2 emission, a significant percentage is coming out from manufacturing. Also targeting this is key in this area to really reduce, especially when the manufacturing is increasing, like you also explained before, how we are doing this, also meaning sustainability, and are giving in the morning also the circular aspect in the car manufacturing example, how we are doing this, what are we using for which technology. This is what we're doing. But this is not only a German activity, it's not only the cooperation in around the world, but we have also, and I see a colleague from France in the room, we have a strong relationship for data for industry projects, where we're using this, where to get interoperability perspective, or Oscar Lazzaro was also on the panel. He is heading in Europe this maintenance project, which is comparable and where we align the activities. How we are doing this, oops, sorry, next slide please. How we are doing this, you know, I've shown very briefly at the end of my presentation tomorrow, in the morning today, some kind of the concrete use cases. And here you have to look again, and the orange box, this was around the sustainability targets before, or the blue box regarding resilience. So we have here specific use cases for sustainability, for sure also to build up a joint kernel in achieving this. For example, easy topic, how we are calculating a broader carbon footprint, how we are doing a battery passport like shown in the morning, but all are contributing to the resilience topic. So this is more the technology level, but when we're going over on a European scale, please next slide, we have set up, and it was rightly, next slide. Okay, it's coming, sorry, it was a little bit delay. We set up in Europe a network for digital innovation hubs, also European digital innovation hubs. And you see here on the brown box on the left corner is, you know, to providing support, also to providing regional support, and we're providing support especially for small and medium-sized enterprises. Also the numbers which I have in mind that from manufacturing, you know, the main part of the GDP is depending on small and medium-sized enterprises. It's in our case is 18-19%, maybe a little bit different from country to country, but a much bigger, Raghu, like you said, where we have really a need in doing this, because a really significant part is depending on small and medium-sized enterprises. So building up a network to support small and medium-sized enterprises, building up also a cooperation between research, academia, small companies, big companies, governments, this is in our case often called public-private partnership on a European level, to target this is key. And you know what we are doing, when you could look in the middle column, we have around 150 innovation hubs which are funded from the Commission, distributed. You know, it's a little bit other situation in Europe where you have different member states. You have then 76 some kind of selected, which are going to also get a regional funding, and is distributed around Europe, around the different regions in Europe. And for sure, we are targeting different sectors. There's not only manufacturing sectors, but also other sectors. We are looking what other technologies which we are doing, and you know, they are providing also some kind of services to their companies with the support of the network which I explained behind. And as you see here, it's also mentioned, but I said it before, it's between corporate, small, big one, academies, investment, and so on. Also on the left, right side and the bottom, where this helix is somehow described. This is what we are doing on a European level. Also first, let's say, some kind of examples of concrete project tasks which we're doing together around Europe. And second, also about how we are supporting especially small and medium-sized enterprises in doing this. What is the content? Thanks a lot for the supporting. We have on the one side knowledge hubs. You know, it can go from helping to get access to finance, could go over to academia to get some training, to have some kind of working groups, and you know, we have also, you see it in the middle, some kind of dedicated working groups or thematic working groups, how is it named here, where you see here sustainability and some others are highlighted. So this is somehow what we want to do and to apply on the European level. And last but not least, I think this slide was in addition, but is also showing a little bit the aspect from the man-machine interface, or machine-human interface, or human-machine interface. You know, we have also set it up, for example, dedicated projects when we have thinking about the cooperation with robotic system. This is only to give you some flavor what we are doing, and also, as said before, agreeing a little bit that we are a little bit showing different parts, but at the end we are targeting the similar goals for us, for our society.
ありがとうございます。一点いろいろな取り
Thank you. One question. In the European countries, including Germany, various different tasks and activities are taking place. Now, how to use digital technologies? There are some direct activities, but there must be other activities, including enhancement of digital literacy or financial support. Multifaceted activities will have to be supported and promoted. That's one point we have in interest. But in Europe, what are the type of systems you have to promote those other aspects?
You know, so now I have to put it again, hear me twice, with a small delay. You know, I said one element on the European level is, and I won't only touch 2-3 topics, is, you know, I mentioned this public-private partnership instrument, where we really bring public, government, could be also research institute, private companies, with a splitting between the investment, you know, and partnership to bring them together, and really setting up some kind of founding projects on the European level to support for the different tasks the companies, the industry, and also academia, because it's a partnership, like I said before. Second issue is to get, let's say, also the infrastructure, you know, we have in Europe, because, you know, it's highly depending on digitalization. So we have to look out how we can increase the digitalization besides the transfer, what I explained before, but looking about how an infrastructure is looking like cloud edge infrastructure and so on. You know, there's some kind of European important project for common European interests, where we especially targeting the cloud infrastructure services, which covering the continuum from cloud to edge. And third topic is there are also some kind of joint undertaking. I have indirectly mentioned this before. In the HPC areas, there's a joint undertaking really to establish also the compute and storage infrastructure, also the HPC systems, to get the availability. This is only 3 elements when you ask me for an European level to get it done and to target this.
ありがとうございます。こういう
Thank you. The 4 pillars in the United States and the European pillars that has been touched upon are quite similar in that sense. Now that we have looked into local situations and building up on this discussion, we would like to bring your attention to the reality. There may be some inconvenient truth, but numerically, how effective is our effort? That is something that we would like to honestly discuss in the next segment. Now, first about labor efficiency, trade liberalization and incentives and digitalization and smart manufacturing. Do they have positively effective relations? That is something that I would like to discuss now. Take a look at this slide. This is the definition of labor productivity in the United States. In Japan has long had a very different set of definition, but about 10 years ago, Japanese definition has been redefined to make it closer to the one in the United States. Overall work hours worked divided by the outcome. Based on that discussion, you can see very revealing numbers. This shows different levels of labor productivity in different countries. On the right is the table that shows you exact numbers. And compared to European or OECD countries, Japan's labor productivity is rather lagging behind. Further, take a look at this chart. In the 80s all the way to present, this shows the changes in labor productivity in the United States. Horizontally, it is the timeline, and vertically, labor productivity is shown. From left to the area that is colored in green, this was at the time of the global financial crisis. Labor productivity in the United States has grown in a very linear manner. But after the global financial crisis, and to our amazement, as highlighted in red, during the stage of Industry 4.0, U.S. labor productivity has stagnated. This is an example in the United States, but similar pattern can be found in Europe and in Japan as well. The point is this: Industry 4.0 outcome and labor productivity. How should we interpret the correlations between the two factors? Are there any positive correlations, or have we been effective enough in pushing labor productivity? And this chart shows the level of liberty at trade based on the numbers from IMF. From 1870, 150 years ago, all the way up to 2020, shown horizontally. Rightmost red portion demonstrates that the trade liberalization has also stagnated after the global financial crisis. Labor productivity and trade liberalization, is there any correlations between the two? This is just a hypothesis, but all the way up to 2008, high value-added work was something that every country wanted to retain within the national border. And work from less with less added value was something that they wanted to procure from outside countries, and that was how countries tried to improve their labor effectivity, and this is still at a hypothetical phase. Let's take another perspective. This slide shows you the salary level by the industry. As you can see, information industry, management of companies, different sectors have different levels of salaries in terms of average salaries. As you can readily see, manufacturing sector is near the bottom. Manufacturing industry compared to information industry, there is less economic incentive, salary-wise. Similar analysis have been carried out in Japan by the Japanese government. This shows the salary situation in Japan as well. As was the case with the United States, labor productivity, electricity, gas, heat supply, and water supply is the utility industry with higher level of salary. And manufacturing industry is lower in terms of income incentive. The point of our argument is this. Labor shortage in the manufacturing industry. What is the root cause of the labor shortage? And that is a fundamental question that we need to discuss. One of the major factors for labor shortage is often blaming declining birth rates and aging of the society. However, isn't it really the less economic incentive provided in the manufacturing industry that is resulting in the shortage of labor? That is another question that we have to revisit. Hence, labor productivity, liberalization of trade, and economic incentives are the factors contributing to labor productivity. So based on these information, I would like to ask Dr. Hahn, in terms of income incentive, what do you think? U.S. and Japanese situations have been compared. What is the situation in Europe?
When we're speaking about impact or why we have this labor shortage is for sure in our country maybe not so much the salary perspective, maybe not so dramatic. It's more really the shortage and the motivation from people to going in this area, but we can discuss this later. When you're asking me, also here from a company which is international active with production, development and research, yes, in the US where we have also a big research site in the Princeton area, we're facing the problem with the high salaries and a little bit decreasing of people working in this environment for manufacturing. This is in the US. When you're looking in our case, also in Germany, Europe, is more the shortage perspective which is influencing us. And in the East, when you're going to the East, yes, you get again here a little bit the effect like we've shown before. But in general, it's a factor. It's not black and white, and it's also depending in the international activity in which region you are. So I cannot comment on the Japanese numbers. I know this from own experience in the US because it's the difference of the salary because we are losing several people in this area. In Europe, you have a little bit of mixed picture and would be careful only to highlight this. This is more influenced by the motivation. Is this a nice job which you have to do? Is this job fancy enough? You know, all this in Europe is called mind. You know, take it STEM topics, but quite comparable. That's more what is influencing in Europe. Also meaning salary, US, Japan, I cannot argument salary in US, yes. In Europe, a little bit a mixed topic, and we have also to address has certain maybe also cultural reasons.
ありがとうございます。白か
Thank you very much. So it's not black and white. Project members, including myself, do understand But by clarifying the overall structure in 3 regions, we will be able to discuss the possible effects of the programs that are going on. Now, declining population is a constant concern in Japan. Now, Professor Kimura, if you look at labor productivity and declining birth rates, especially from the US friends, it's more like a lower incentive for having this low labor productivity. Again, this is not white and black. If you look at the overall Japan situation, what is your observation? So in terms of declining birth rates, I'm not quite sure. In the US, I think there are different factors impacting because there is high level of movement of immigrants across the border. And in Japan, we have more rigid population movement. So the environment, demographic environment is different. The lower wage level in manufacturing, could it be a major cause of having this lack of labor? I think the mindset or the overall labor culture may be a bigger reason. And plus, this labor shortage is, of course, impacted by a declining population. In order to cover this loss, we are asking the high age group people to work extensively, including women as well. If they join the overall labor force, I think this will reduce or lower the labor productivity. So that is the reasons why labor productivity is very hard to improve. For the past 10 years or 20 years, there has been technology development stagnation in manufacturing sector as well. And I think similar situations can be found in Western world as well. So in terms of productivity, there are multiple factors impacting. So it's not there's no way explaining this, citing simple reasons. One thing I can say here is in Japan, it's very important to increase the wage level, and that's important. But another thing that is as important is the recognition of the importance of manufacturing sector to society. For many years in Japan, manufacturing industry has prospered. And in recent years, that success is not widely recognized. Although this is my personal opinion, that could be another reason. So there are mixed reasons for lower labor productivity. And you talked about the stagnation of technology development as well. So our approach, the solutions have to be multifaceted as well. And this can be a common issue throughout the regions, including Europe and US. Now, Professor Athinarayanam, you have a very clear chart that's been presented. After the financial crisis, labor productivity, according to this chart, has stagnated. It's not increasing as quickly as before. What are the reasons? What are the hypotheses? How do you analyze the reasons for this stagnation? What are the major explanations in the United States?
Thank you for the question. So perhaps for some perspective, we need to look at what happened in the past, because history repeats itself, as they say in the US. So if we look from the period between 1990 to 2007, until the time when we hit the global financial crisis, so the growth rate, the productivity rate, I would say, was rather high. In fact, to be exact, it is about 3.6% annual productivity growth rate, and the cumulative increase in the manufacturing labor productivity in that period from 1990 to 2007 was a whopping 95%. That is pretty high. So what were the key drivers? The key drivers were capital investments. As you can tell, prior to 1990, the graph is pretty flat. And if we go back a little further to 1970s, which is when Industry 3.0 came into mainstream manufacturing, you can tell that between 1970, when Industry 3.0 came into the scene, and 1990, things were rather flat. So the uptake of that automation, information technology, took a little time for it to get into mainstream manufacturing, right? So there's about a 20-year gap. And from that point onwards, we see the graph going up very rapidly, the productivity. And we also need to keep in mind, globalization was also very rampant between 1990 and 2007. So what did that mean? So we were depending on global supply chains, meaning that we were taking the low-value manufacturing and exporting them to other countries, right? And in no bad way I mean this. At that time, China was becoming the factory of the world. So many Western economies were dependent on Chinese manufacturing. And U.S. was no different. So the productivity became very, very high. So like I said, it's 3.6% growth rate. A typical growth rate in the US is about 1.5%, but this is a 3.6% growth rate and a cumulative growth rate of 95%. So let's look at what happened post-recession. So post-recession, things kind of stagnated because really the productivity went from 3.6% to 0.7%. It decelerated quite rapidly. And one of the reasons is, well, obviously the global financial crisis, meaning that there's lesser capital investments in manufacturing, and also the slower pace of innovation and also the technology diffusion, meaning that they have pretty much plateaued on how much and what they can do with Industry 3.0 by that time, right? So, I wouldn't say there's really nothing much else to do, but they have really peaked. So the next wave is where the Industry 4.0 comes in. So that is, this chart shows around 2011 when Industry 4.0 started in Germany. But keep in mind, the first Manufacturing USA Institute to address the needs of Industry 4.0 in US manufacturing did not start until 2016, 2017. So we are looking at a period, we're going to have to look at a period where this technology has to sink into the mainstream of US manufacturing before we see a quick uptake of Industry 4.0. Similar to the graph that you see in the left, right? It took about 20 years for 3.0 to really take effect. The question is, how long will 4.0 will it take for it to really take effect and become mainstream into US manufacturing?
ハーンさんがたくさん言いたいことがあるそうですので、はい、ハーンさん。
Dr. Hans, you seem to have many comments to say. You have the microphone.
Maybe to put also an additional flavor on this, being long in the automation business and looking until, let's say, in the 2010 years, not looking at the supply chain and where you're manufacturing, but looking at the technology aspect, where you're increasing the productivity on the shop floor, which is also increasing then, the calculation about the productivity. And when you're looking at these graphs, then you have, in the 80s, in the 70s, maybe not so flexible programmable devices to support automation processes. In the beginnings of the 90s, in mid of the 90s, you know, all this decentralizing coming, where you have also distributing compute power on a shop floor, which then increasingly, and you see this after 2000, the productivity, also technology aspects, you know, this is not so flexible controlling part, to have the free programming controllers in the 90s, starting with 95, significant decentralization with a possibility, and we know this all to have the computing power, you know, close also to the processes. You have also supervisory system coming on top, and when you're going then to the 2005 to 2010 area, where you have also with the capabilities from cloud and also the huge computing power and the huge connectivity, also not only on the shop floor, what I mentioned before with the decentralization, but also the connectivity and computing power, where you can again optimize this. Also meaning we have, I agree, don't ask me if this is 1% upper or lower, but in general, this is also technology topics. When you're now going to the area of Industry 4.0 here, starting with 2010, 12, 15, right, but there are two topics. Maybe with also some kind of a little bit paradox behavior when you're looking at the calculation, because also the flexibility stuff is coming into that you have really to react faster on topics which are not directly seen in the productivity number. But not to say this, that is, we have only to wait until this come or have to change the formula. That's not the topic. But we have also to look how we really scaling up this in a broad area. That's what we discussed before regarding the small and medium-sized enterprises. And this for sure will be the tough work which we have ahead of us in doing this. And the next tough work is we all are trained here, personal comment, in the classical computing, automation, but now we are coming into the area of the data economy, data ecosystems, where we have to train. Maybe we have a little bit of time slip. Maybe we have to look how we calculate this. But for sure, we have to do much more in the scaling up in the digitalization area.
技術革新とそうですね。
Right. Technological innovation and social innovation, there is a time lag, and that's commonly understood among the world. Now we are working on Industry 4.0 and digitalization. The effect of digitalization, when will we be able to enjoy the fruits? I think the society has a lot of expectations. So we are the experts, and we need to be mindful for such a time lag, and explain it to the society. Another topic of offshoring. You talked about China, and including the topic of offshoring, when it comes to the productivity, current productivity, you will need to discuss offshoring. But indeed, we are, the human beings are faced with planetary boundary and human well-beings. Now, we need to consider how to enhance the allocations of what we have to do. And we hope to be able to continue the discussion into the future. We have a lot more we would like to discuss, but we would like to have more in-depth discussion on those topics. Now, about jobs. With digitalization, smart manufacturing, the jobs, the occupations, what is happening currently and how will it change in the future? That's the topic I'd like to discuss. We would like to discuss in more detail. The slide shows the World Economic Forum discussion about new jobs and jobs to be lost. What will be the prospect? Not today, but for the next 4 years. That is until 2027, what type of jobs will increase, what will be lost or declining. This is the data from World Economic Forum. And if you look at the blue bar chart, As you can see, the AI or machine learning experts, sustainability experts, they will be the new jobs to be created as is reported. What will decline, as you find on the right, the statistical finance and insurance clerks and the public servants, those are considered to be jobs to decline in the future. Now, this is one trend, and we might accept this. But as a social system, how efficiently can we transform our system? That's what we'll have to think about. And this is not just for Japan, but in Western countries, STEM education has been a hot topic. We want younger generation to be ready for these new types of jobs. That means STEM education for young people will be needed. But is it sufficient around the world? Is there a possibility to have a global collaboration in STEM education? That's another topic. And it's not just for young people. There could be a lifetime education, because we want our labor forces to be flexibly dealing with changing jobs. Smart manufacturing and digitalization topic is what this is. Now, when it comes to education, and another perspective is gig workers, which is a social trend that we are looking at. The slide shows the overall situation of gig workers in the United States. I will not discuss details, but as you can see, one characteristics here is the large percentage of gig workers in the industry are not just workers in retail or the manufacturing, but the skilled laborers. Like 54% of gig workers have a 4-year college degree or higher. That's for a fact. Also, the slide shows that in the United States, technology, connectivity, digital platform has progressed, and it's become more easy to merge gig workers into manufacturing industry. And in 2021, 11 to 15% of the overall workers in the manufacturing industry had been either temporal workers or workers on contract. Well, maybe this situation is somewhat different from the Japanese situation. However, in retail business or the maintenance workers, frontline workers, in gig workers, but even in specialized field, new ways of work, new ways to work seems to be spreading, and this could be a viable hypothesis here. The slide shows the survey data from World Economic Forum. What would be the workforce strategy prospects in the future, not today, but into the future, the result of a questionnaire survey. The bar graph shows the percentage of organizations that plan to adopt such human resource strategies, and what is the most common investment strategies and least common investment strategies. But as the blue line in the middle shows, wherever they are, outsourcing or offshoring is how we discussed earlier. The companies consider geopolitical risks. That's what you can read from this outcome. Not just outsourcing to foreign countries, but education and automation within the country. For both of these aspects, companies are willing to make investments. Now, the point here is that, well, let's say we understand this data as fact, but including gig work, such human resource strategies, do you think they are being effectively implemented? What are the issues and what are the points of collaboration among different countries? Those could be the points of discussion. Mr. Hahn.
新たに生まれる
Newly emerging employment and disappearing employment. Transformation of work. There are areas of work that are increasing, and there are areas of work that are decreasing. How do you effectively promote the transition from decreasing work to increasing work? Is there any initiative? in the private or public sector to promote the healthy transition of workers from one work to another?
Sorry for the delay, this was the translation. No, first of all, you know, your study, you have shown also the overview where you have the decreasing jobs and the increasing jobs where you have the demand of data analytics, AI, and so on. It's not surprising for me. And that you have on the other side, on the right side of your slide, the decreasing job. You know, I thought in my preparation a little bit, one was, as the last time, in physical at a bank myself, you know, this was one example which, you know, so meaning this also where automation influence the decrease in the jobs of the one side, and on the other side increasing job possibilities, which was shown on the slide before on the left side, where the AI data people and so on were super high ranked in the increase of jobs. But the question is behind how we are addressing this, you know, and there's different flavors. You know, one I mentioned indirectly before when I spoken about the digital innovation hubs in Europe were setting up huge programs exactly, and you have maybe seen, and I highlight this, that they have also an academy offering really to help small and medium-sized enterprises to get and training and to have these people re-educated or trained on new topics which are requested now. So this is, let's say, so official. When you ask me as a company representative, I can tell you we have developed some years ago some kind of knowledge radar. And in this case it's easier, also where we need the people, this is a knowledge radar, and on the other side we have also, and you know this because you know the people in the company where the people are at the moment, then you can really make it dedicated programs to develop the people, to educate the people in the right manner. I can tell you from my personal experience, we are also from the company perspective pushed in doing this. So every day when we are opening our intranet page, we see how many hours in average our colleagues are trained and what is my status. So you get it also visible, but this is, you know, so one side is motivation and the other side is a little bit that you have the right program outside. And the last topic I want to mention, because when we are scaling about small and medium-sized enterprises, spoken about was Europe, especially with the digital innovation hubs and related programs, are doing a perspective from a company. You know, we have also in Europe huge industry association where typically most of all our small and medium-sized enterprises are members, and they have also installed access points, academies, only to have dedicated training courses. There's a multi-topic. We are aware of this. Have we found the complete solution? Maybe not yet, but we are starting this. And the problem which you mentioned with science, technology, engineering and math, STEM, at least in Germany it's called Mind, Math, Informatics, Nature and Technology, but it's also different abbreviation maybe for a similar topic, really to motivate people to go into this area or to move into this area, going in as a newbie in the job, moving in this area. I can tell you we have significant investments doing meeting. You have family days, for example, or at school days, or you are distributing some kind of toys is the wrong word, but maybe I name it toys, but to get with a technology-friendly stuff just from the beginning. Also multi-dimensional topics which are addressed in this area.
Thank you. Personally, I feel that in Europe, academia is playing a major role in promoting people to be better adjusted to new technologies. And there is also a support or advisory services for people to transition from an old, disappearing industry to new and emerging technologies areas. That can be a very good experience that we can learn from. Professor Asinarayan, academia and the private sector relations. In the United States, as has been touched upon already, Industry 4.0 initiative is now being promoted jointly by the academia and the private sector, as is the case with SESME. So to promote transition from old industry to new ones, what the private sector and academia and the government can do, and what is the policy or the sense of directions is being promoted by SESME, for example?
Thank you for the question. So when it comes to this topic, I break it down to 3 areas. How do we train new workers? How do we upskill existing workers? And how do we prepare the next generation? So the part of training new workers and upskilling existing workers, that is being addressed in a large way by MEPs. I was mentioning earlier in my talk that MEP that is part of NIST, they are working with the Manufacturing USA institutes like SESME. So I looked at some data. In 2022, Manufacturing USA Institute combined all the 17 institutes. They trained and upskilled 106,000 people to prepare them for the next level of work that is associated with Industry 4.0. So that takes part of the training and skilling. So I'm assuming that trend will continue. If anything, the number of people who are going to get trained and upskilled is going to be increasing in the United States, because that is really the mandate of MEPs and also the Manufacturing USA Institute. So the Manufacturing USA Institutes, like I mentioned, they create newer technologies. While they are creating newer technologies, there is also an expectation that they create training materials so that the people can get trained and upskilled on it. MEPs, their responsibility is to ensure that the people get trained, whether it's on newer technologies or even some of the older technologies. So now let's go into education. Now education, this is a very different animal. In the US, I'm in higher education. This is my 31st year in higher education. I've been a professor for that long. And I'll say this, and I'm not ashamed to say this. The higher education is very, very slow to catch up with Industry 4.0. Many higher education programs in the United States, particularly at the 2-year level and the 4-year level and higher, are still very much embedded within Industry 3.0. So while we talk about digital transformation happening in industry, we must not, in the US, that's one thing that I preach on a daily basis, we cannot forget the fact that even higher education institutions have to digitally transform so that they are aligned with the needs and expectations of the industry, so that we are preparing the next generation engineers and technicians so that they can operate and be effective in this Industry 4.0 environment. So that is, I would say, a few years ago that was, was rather slow, but it's slowly picking up. And a case in point, like I mentioned, I'm from Purdue University. We actually received funding, quite a bit of funding from the Manufacturing USA Institute and also the Department of Energy. And equal amount of funding, perhaps more funding from industry so that we can digitally transform our programs at Purdue University. In fact, we just launched that program called Smart Manufacturing Industrial Informatics last year. Very much aligned, one-of-a-kind program in the United States. In fact, we were featured in the National Academy of Sciences. They featured 2 programs. One is from MIT and the other one was from Purdue on how to digitally transform manufacturing programs so that we are preparing the next generation.
Hahnさん。
Yeah, only on one small comment. Fully agreed. I touched this indirectly. This 3 topics: retraining, education, and really the third topic. But also the education systems, and especially when you're on the borderline between education and to get it ready for the job. You know, maybe it's also good to look inside. You know, in I think only in Germany we have this dual education system where you have on school in parallel you are at the company, which are also some kind of instruments which we are using to target, you know, this skills gap which we are facing with the changing jobs like this described before. So there's only one additional comment which just come in my mind when you spoken about this.
ありがとうございます。足並み
Thank you. Professor Ashinarayanan said that training, skill improvement under MEP program, and I know that it's a very functioning program. You have to understand the current status, know what is a gap, and then try to fill the gap. It's a very convincing approach. And at the same time, seen from Japan, NIST is really a promoter of advanced technologies, and NIST sponsoring this MEP is really a surprising fact to many researchers in Japan. So in terms of gap, how can we quickly close this gap? As Dr. Hahn said, I think this is a common problem universally. We need to continue to promote technological innovation, and it has to be people who can innovate. So we really have to make as much effort to improve human resources as well. Now, Professor Kimura, as we discussed this topic, you mentioned earlier manufacturing industry is critical to Japan. And you also said that it's important to change the mindset of the manufacturing sector. Historically, we've had traditional mindset, which is now the DNA of the traditional manufacturing. So traditional DNA, the old jobs and new jobs, and the need of transformation to fill the gap. So how should we understand this bridging? What does society have to do to close this gap? There are positive and negative sides to this transformation. Good side is that Japanese employees do not have high expertise. And when new jobs are created, there is a lack of flexibility to adapt to new jobs. But if we have, so we have to have a good training system to bridge the gap. And it used to be individual company that provides education, but in this new world, it's very possible. It's not possible for individual companies to fill this gap because each individual company is trying to catch up with the trend that they see in the Western world. And they cannot have a choice to wait and see. So I think this needs to be promoted by a whole nation, the national government. So in that sense, multiple educational opportunities should be provided by the national government, especially in the highly specialized area to practical area. And there are multiple organizations that are already set up to provide education services. And there are new schools set up. So in terms of framework, we do already have a scheme. Having said that, in terms of STEM education, what we need to do is already clear. and this needs to be incorporated into a higher education system. But then in order to meet societal needs, upskilling, reskilling, I think this area is where Japan is lagging behind. First of all, we don't know exactly what is the current status. So if you look where we stand today, we have to understand where we want to go in the future, and based on that, we have to design our training. And that is not available today. Japanese people are now more active in terms of job hopping, but the industrial structure has not been changed. In addition to that, in terms of gig workers, in the manufacturing sector, there are contract workers. Maybe this is not within the scope of gig workers definition. Non-regular workers ratio is currently increasing in the manufacturing sector. In US, the ratio may be 10 to 15%, maybe a little lower than that in Japan, but I think the way people work has been changed, and there is much higher labor movement between companies. It's not just factory workers, designers and engineers who have expertise in advanced technologies. They are actually changing jobs more frequently today. So new labor market is now being formed, which is similar to gig workers. And this can also be another challenge that we need to cope with. In terms of gig workers, in the United States, this topic has been presented as we are discussing in a project. We do observe similar signs of gig workers' rise. So what we have to do is to quantify the number of gig workers. And so Professor Kimura said STEM education, Society 5.0, including public and private sector, is trying to come up with educational system for STEM. But as you rightly pointed out, upskilling in companies and organizations is still not enough. This is my personal opinion, but there is much more we have to do in this area compared to other countries. I think it is clear what Japan needs to do. We have to focus on the STEM, the reskilling area. In terms of transformation, it has to be part of that transformation. I am repeating myself, but what is happening today in society, what is the current manufacturing technology level, how they are able to employ people, all of these questions have not been clearly answered yet. And that is the biggest problem in terms of policy making on the government side. Thank you very much. I think we can continue on our discussion on education, but we only have 30 minutes left. So I'd like to move on to the last topic, last session. We talked about the realistic topic using quantifiable numbers to try to understand where we stand today. Now, if you look at digitalization and smart manufacturing, how can we design the overall direction in those areas? So that will be the topic for the next session. What you see here is the history of collaboration between Japan and Germany. For your reminder, originally Japan and Germany worked on digital transformation, smart manufacturing, man-machine interaction. We've had lengthy discussion for the past 10 years. And through Hakatech, Japanese companies and German companies, academia members, labor unions all got together and discussed on how and what changes we can expect in labor market and in wider society. Back in 2017, 18, or 19, in 3 years before COVID-19, we've had a full discussion on that topic.
That was a time when the labor productivity was different, and this is before COVID era. And this is what we thought before COVID era. This is the message we had 5 years ago. From German people, we heard the word multiverse mediation. That's a key word. And it says that digitalization is not human being replaced with machine, but rather human and machine do not just help each other physically, but the knowledge, tacit knowledge, and explicit knowledge. Through this, the man and machine should be able to help each other. This is the direction we should develop, make developments and change the society. And that's what we discussed. And in 2019, in Acatech discussion paper, we published this outcome. Now, we had the discussion paper. The project discussed the paper. Now, after COVID-19, we have seen several social trends. And because time is limited, I will only cite one example. This is what we received from the United States. U.S. manufacturing collaborative robot. What is the status of introduction, and what are the mind barriers in the introduction? This is the report of survey we received from the American participants. As the chart shows, it's separated by age group. Baby boomers, Generation X, millennials, and Generation Z. In each of the generation, working together human-machine interactions in workplace, the psychological barriers become lower with time. And this is what we found from survey data and reports. Several years ago in Germany and Japan, we had a discussion about certain direction, and the social adaptation is indeed moving towards that direction. That's what we are discussing. On the other hand, however, one major topic of today, industrial sustainability. Concerning this topic, there is a very big international issue or the global issue. Now, human and machine interface, as in the case of the United States, like machines can carry what is heavy. That's the limit of what can be done. It's more physical. The image we had in the past was that the human and machine share knowledge, and win-win situation could arise between human and machine, and in a sustainable way, planetary boundaries and well-beings could find solutions. For example, as we discussed today, technology innovation is still not there. Social adaptation is still not there yet. That's one important point. As Professor Kimura said earlier, now there is a reality. And what is the gap between reality and what we would like to be? That should be mapped to identify what are the issues, where the issues lies, and we will need to map the issues. That's the discussion we are having within the project. For example, the chart shows represents our discussion. Horizontally, we are looking at the time, which is in log form, and left microseconds, middle 1 minute, 1 hour, 1 day, and further to the right, it's 10 years. So this is a logarithmic graph. Now, in human-machine relationship interactions, there are 4 elements discussed around the world: human, machine, material, and the method of interaction in between. In these 4 aspects, what are the behaviors? How should we analyze the behaviors? And how should we optimize these behaviors? In each of the time domains, we have mapped the issues that could exist, and that is the map on the slide. originally, when we had started discussion in Japan and Germany, we said that the knowledge should be mutually shared and support each other. At least in terms of the aspect of the time axis, we had to solve all these problems. Otherwise, for human and machine to share knowledge and information and help each other, that would not be possible. That's really what we are discussing currently. And technology innovation, as Professor Kimura said earlier, in such a long time, in the world around right now, there's no single system. We need to accept the fact that there is no single system, which means systems of system will be necessary. Multiple systems will have to collaborate with each other to function as one system as we try to find a solution to social issues. That could be one point that we are discussing within the project. Now, today, this morning, Germany, Japan, the representatives from respective countries talked about data space and various other measures. For example, how could those discussions be mapped in this time domain? For example, know-how skilled work, it probably comes to the left, but task for collaborative robot will probably come in the middle for a second to a minute. But Microsoft order the response by people that cannot be achieved by collaborative robots yet. We still have a map of what can be and cannot be done. That's represented on the map. And the order of decades, like energy plant maintenance, social infrastructure maintenance, how should man and machine collaborate? We don't know. We don't even know if the data can be maintained 30 years from now. That's the level of our technology today. Now, system of systems, collaboration among systems, how do we deal with those questions? Those are the points we are discussing right now. We talked about digital product passport in the morning. Digital passport, according to our hypothesis, is to the right bottom in the current coverage of work, and to the left or towards the top, data generated by people, human beings. We have digital product passport and digital space to work on, but this is the challenge for the future. We still have yet to work this out. Now, what about industrial sustainability? Commonly, we have to find solutions, and it has this much breadth. Our technology solution is still fragmented. There is time lag in social adoption. We need to be aware of the current status as a fact, and then find solutions to promote adoption. That's what we are discussing, and we want to find answers. Now, in the end, from panel members, I'd like to have your opinion. Mr. Hahn, digital product passport and data space. We covered many European activities today. If you look at the chart, you know that there are still many things to be done. Industrial sustainability realization requires a lot more to be done. For example, digital product passport. In the future, how will we move? When will we cover this chart in the future? And to do so, what do we need to discuss within international collaborative discussion? What are the future issues that we need to discuss? That's what I'd like to ask you to give us your comment on.
Okay, big question, but I'll try to answer. You touched the topic regarding the digital product passport, what we have to do on an international level. Only as a recap in the morning, and I'm agreeing with you how you placed this coverage by digital product passport, where you have behind this topic, the value chain management, planning, circular aspects, and so on. And that's what exactly I've shown also in the morning, how a digital product passport for a battery, it's a battery passport, from producing the elements up to the recycling is somehow increased. I think what we have to do and as you know, also the digital product passport is also one of the regulations which we have to fulfill in Europe, and I think Sebastian or Ingo mentioned this also before. It's not only the regulation part; it's also opportunity for new businesses. Also, when you're speaking about companies, yes, we have to fulfill, but we're looking always what we can doing how we to increase business. The meaning for the digital product passport, I think, and this is one activity we started in the context of this International Manufacturing X to get a framework about. You have seen this in the y-axis in the morning at my presentation. What are the categories? Knowing that we have to the categories so to adapt that we have to adapt to regional requirements. I'm not used to the word regulation, but regional requirements. It could be a regulation about reporting. It could be also some specific laws which you have to fulfill. But I think it would be absolutely, because the supply chain are international. Anyway, we have to think about how we are doing this. But I would be quite happy when you're just asking me on this right corner on the button about coverage of digital product passport, that we're really targeting, get an overview, a framework, what a digital passport globally can look like. Respecting the regional needs, which I always highlight, because one fits all will be not the solution. Also when you ask me doing this, and this is one task which we are just at the moment addressing.
ありがとうございます。ご指摘に
As you have rightly pointed out, industrial sustainability is something that needs to be discussed at the global level. So as Dr. Hahn have rightly pointed out, digital passport can be a scheme through which we can explore the implementability. Experts and the private sector can join together to achieve the best solutions for the entire needs. Okay, Dr. Ashinarayan, you previously mentioned about the US situation. Man-machine collaboration or man-machine collaborative robot was discussed in the United States. Collaborative robot mechanical movement and collaboration between man-machine is something that I would like to ask about. In terms of innovation in the United States, collaboration not only with the robot, but also with AI apps as to how to allow human knowledge to work together with other technologies, including AI. Say, for example, a task of collaborative robot, more real-time or longer time domain collaboration between man-machine can possibly be achieved by leveraging generative AI. I believe that that will bring about a number of opportunities, including AI, man-machine collaboration in the United States. Do you see any prevailing directions, or are there any discussions in the U.S.?
That's a great question. Thank you. And so I will say this. We are very careful about introducing robots, particularly in the small and medium industries, or even showcasing what robots can do. We make it a point that whether it's a collaborative robot, whether it's AI, machine learning, or generative AI, whatever it might be, it's only there to augment the human capabilities. So to make them work more productively and, create better outputs, right? Because one has to keep in mind what happened in the United States during the period of 1990 to 2007. There was a lot of globalization happening, meaning that many jobs went away. So when we bring up the topic of robots, immediately the idea that a robot is going to replace me is going to be going into their mind. So we address this topic very, very holistically. So when we say that we want to augment a human, augment their capabilities with data, the data can be coming from a robot, from a collaborative robot, from an industrial robot, from a mobile robot, from a machine that is engaging in AI. So we address that in a very holistic way, because the region that we are in the United States, we are in the Midwest, which is the hub of manufacturing for the US. So we are very careful in saying that, okay, you're going to be working with the robot, even though it is happening, but I would say that it's not mainstream, right? Now, I think the key to augmenting the human is the human being able to adapt to the robot. So if we say that the robot is going to augment the human skills, so the human has to adapt to the robot, and on the same token, the robot has to adapt to the human. Now, how do we achieve that? So there is a gap right now that has not been, bridged yet. So that work is still happening. In fact, one of my colleagues that Dr. Nanaka also know, we are looking at how do we bridge that gap on creating the adaptation so that it's a seamless. Because right now, the human-robot collaboration is not very seamless. How do we make it seamless? And how do we reduce the level of anxiety, particularly with in the US, the baby boomer generation and the millennials, as to this robot's not going to be taking over their jobs, right? So we have to address the social issue, we have to address the technical issue. So and those things are being worked on. And I would say that even though collaborative robots are pretty popular, maybe in Europe and Japan, but in the US, they are not quite mainstream yet.
Thank you very much. There were lots of interesting keywords. Robot exists to augment human capability. And human societal system, what needs to be augmented in the society in leveraging the strength of robot? And these are the elements that I found interesting. Society 5.0 is a human-centric society. And it's been a while since this concept has been upheld. As Dr. Asinarian mentioned, human capability needs to be augmented. But if you look at not only the relations between man and machine, but you really have to pay attention to relations between social infrastructure and human beings. There are lots of artifacts and machines in our everyday environment. And all these artifacts needs to be used to enhance human capabilities. And that has been discussed over a long period of time. But Professor Asinarian and Dr. Hahn reveal that industrial sustainability, what should be the challenge? In Society 5.0, we are yet to fully cover the challenges that may arise going forward. What do you think, Nonaka-sensei? Japan used to be a major robot power, but Japan was strong at robot technology, especially in terms of hardware. But if you look at different actors, including thought leadership, how should they be engaged and embraced in exploring the capability of robots? And human centricity is a concept that can sometimes be misunderstood. Suppose that we have a goal and we have a certain system to achieve that goal. And you have drivers who play different roles. And these roles are being performed either by a human or by a machine. And then you have to consider whose well-being is to be enhanced. But the well-being that can be achieved depends on the environment one finds itself in. And that is a sort of discussion that is not well promoted in Japan. So both man and machine will be working together to achieve a certain goal. And human being needs to be able to adapt to certain requirements to achieve that goal. However, there are variants among individuals, and different individual may have different level of adaptability. And recognition of such diversity is at the core of the concept of human centricity. SIP has also paid attention to that essence as well. Let me add one point. Model-based approach. You have to create a model with the knowledge available to explore what can be performed by human being and what can be performed by machines. In doing so, it must be ensure that individuals are allowed to adapt to the different environment to attain higher level of inclusivity.
ちょっとなんか言葉足らずになります。以上ですね。
ありがとうございます。
And that's all for myself. Thank you. True. In the beginning, we talked about productivity, labor productivity. That was the icebreaker question that I presented to you. And as you said, it's just one indicator. And sustainability includes many more aspects than labor productivity. So we have to cover all these different perspectives. At any given time, we have to look at the whole time lapse of the system and also of humans, the way they work. And we have to encompass all kinds of diversity to design the future society. That I think is a new direction. Dr. Hahn, what is your observation?
It was not completely working. Hopefully, I answer your question. No, but maybe to add on the comments regarding use of robots, collaborative robots, or the different flavor of robots, and looking at. I put it not by chance example of the AI-based robotics project. By the way, this was also initiated in cooperation with Professor Kagemann, which have shown the report before. I think we have in Germany and maybe also in Europe not so the big topic regarding use of robotics systems. It's maybe a little bit different also from the history, from the Midwest, which you mentioned. This is maybe a different starting point. Where we for sure are key inside is it's one issue, human centricity, which is mentioned. Then, data sovereignty. Also use of AI, so AI-based robotics, AI Act when you're looking at the European level, but you have also in the US this executive order regarding AI. Also we are more keen not in the system regarding robotics per se, but in comparison to US we have other history, more in the usage or misusage of technology and information. So this was regarding Data Act, Data Governance Act, which Boris mentioned in the morning, or AI Act, and what you are doing with this.
ありがとうございます。非常な、
Thank you very much. So we've had very good diverse opinions. But in the end, from all the participating audience, we've received many comments. Just want to introduce one comment. So I'd like to introduce a comment here. This is an essential point. Professor Ashnara Yanan said Industry 3.0. We need to look back on what has happened in history. That's a comment, really. Industry 4.0, before Industry 4.0. We should examine pros and cons before that. SDGs were not there. But it's important to have this mindset to protect the environment. I think the negative aspect brought up by Industrial Revolution, they have not been resolved. Industry 4.0, will it present solutions for us? Can we find good middle points? Industrial Revolution, Industry 1.0 and onward, we've discussed pros and cons. Of course, they come with problems as well. And many members in the audience pointed out the problems that we face today. So based on the history, what would be the best possible pathway going forward? So I'd like to go around the panel, starting with Professor Ashinarayanan. Based on this comment that I just cited, would you like to give your observation on this?
So I'm not from the industry, I'm an academic, but I'll try my best to answer the question. So my answer to Industry 4.0, the path to Industry 4.0 is through 3.0. I believe there's the foundational, there's the foundation you need, because if you look at what happened in Industry 3.0, we automated a lot of systems and we collected information, we used that information, but what we have done with that information was we were reacting retrospectively, meaning that when we collect the information during the age of Industry 3.0, we were looking at, well, if something happened on the output end, why did it happen, where did it happen, and how can I prevent it from happening in the future, right? So it's a very retrospective strategy. But when we move into 4.0, 4.0, in my opinion, is about digitalization, data utilization, and visualization, right? Now, not only, so with the data that we have right now on hand, with the capabilities of AI, machine learning, not only we can look at the retrospectively, we can look at the historical data and we can predict the future. That is the value that Industry 4.0 brings to us. Because if you look at, there was a report that came out in 2016 from NIST on making a case why US should adopt Industry 4.0. I'll just give you one example on how do we improve the OEE, meaning that operational and equipment effectiveness, so that the line can run continuously. They said that if we just do one thing and one thing only, meaning predictive maintenance, right? So predictive maintenance used to be very reactive. Maintenance used to be very proactive, which was not economically feasible for everybody to do. But if we can, I'm sorry, it was not so it was scheduled maintenance and reactive maintenance. Now with Industry 4.0, we can go to the level of predictive maintenance. In fact, if you want to go take another step further, we can be more prescriptive maintenance. So I think that's the value of data. That's what Industry 4 does for us. So the path to 4.0 is you have to start at 3.0, have all the assets, have all the capabilities, and improve all the systems the best you can, and then now improve it and bring it to the next level when you come to Industry 4.0.
ありがとうございます。今日の議論ありましたように、足ナラヤン先生が。
Thank you very much, Professor Ashinarayanan said exactly. He said, Industry Revolution, people were concerned of losing jobs. But Industry 4.0, the focus is on how to use data. How this use of data impact human society negatively, that is a concern. For example, EU Commission has covered a lot of discussion on how data should be utilized. And we are watching how these rules are formed. Now, Dr. Hahn, on this comment from one of the audience, Industry 4.0, how should we consider this? Any comment on this?
Okay, industry, I think the explanation to use data, to get value out of the data, to optimize processes and to look to new opportunities, you know, in comparison to Industry 3.0, where we increased the automation, which I mentioned also in the previous discussion, or also in 2 and 1.0. I'm just looking because, you know, with introducing of Industry 1.0, of course, we not used the word during this time, but there was in German language a Weberaufstände. I've said Schlesien Weber uprising, which are creating, of course, some kind of disturbance in the topic. So meaning, coming back to Industry 4.0, I hope we are more clever in preparing the use of the technology, and that we have not this hiccups like I just mentioned as one example in 1.0. Maybe one comment to Industry 4.0, because I'm from the beginning in this area. And you know, we have in Germany and also in other countries a working group regarding impact on work environment skills. An impact on work environment, there was first of all, with all the Industry 4.0, with all the digitalization stuff, we are losing jobs. Now we are looking, this has changed, we are looking how we compensate that we have a shortage of workers or of people. So meaning also that hopefully that we have some kind of methods in place that we can handle this.
ありがとうございます。新しい技術をどう社会
How to maximize the benefit of the new technology. That's really the essence in the discussion for 4.0, and I think that was a very encouraging message. Professor Kimura, what do you think? Well, someone's already mentioned this, but Industry 4.0 compared to 3.0, the differences in terms of physical aspects and the knowledge world, many things will be enhanced. And you may not agree to what I am going to say, but it is an enabler, just a tool to enable something. But what do you want to enable? That will not come out of Industry 4.0 because the society as a whole still do not fully understand what 4.0 can offer. Unless the society understands, it cannot accept. Good understanding, good agreement, what vision to adopt, and in the end, what are the measures and structures to introduce 4.0? That consensus is necessary. 4.0 itself is not going to present the outcome. Right now, the discussion focuses on technology, but what can technology do? That's what we are discussing, but what do we really want to achieve? I don't think we have discussed that yet, and this is what we will need to discuss. The discussion should not be too general, but we need to think of those points, and the direction will be presented based on social consensus. It could be in the United States, Europe, or Japan, and we are all different, so we have different consensus. However, the foundational technologies is common, and we need to reuse the technology. That's how I see. I'm sorry, I was too general. Thank you very much. Mr. Hahn, Dr. Shinarayan, and Dr. Kimura, thank you very much. We had 2 hours discussion, very candid and active discussion. Thank you, and this is the end of session 2. Those of you in the room, please join me to thank the participants once again. For those of you who are here and those of you online, thank you very much. Now, let me inform to you the schedule for the rest of the afternoon. From 4:15, we will start session 3. In session 3, we will hear reports of cooperation between Japan and Germany. We hope you will continue to participate. Now, if you are leaving, please return the receivers for simultaneous interpretation at the reception. And now we are going to take a short break.
じゃあ話しますけどいいですか？はい、大丈夫です。もうあと1分弱で始まりますので、ご着席を。
We'll be resuming the session in about a minute. Please come back to your seats. Thank you. Now it is time to resume the session. We would now like to start session number 3. The session will be moderated by Serizawa of RRI. In session 3, we will be discussing the collaboration between Japan and Germany. Industry 4.0 and RRI joint statement was the basis for the promotion of the expert discussion, which will be reported at this session. Before doing so, we would like to receive some words from the both governments. First, from METI, we will be receiving the speaker from METI, Mr. Suga, who was not able to make himself available. Principal Deputy Director, Manufacturing Industry Strategy Office and Industry Bureau, METI. On his behalf, Mr. Majima will be reading his notes. Thank you very much. I am Majima of METI. On the occasion of the opening of the third session, I would like to deliver the message of Suga Chizuru. Today, congratulations on the occasion of the successful organization of this event, and thank you very much for your attendance to this event. Dr. Hess of Federal Ministry of Economic Affairs and Climate Action and other experts are warmly welcomed again to this meeting. I would also like to take this opportunity to express our heartfelt appreciation to everyone at RRI. SDGs was signed 10 years ago at the United Nations, during which period social innovation for sustainable society has seen the conclusion of sustainability-related initiatives. Manufacturing industry, through IoT usage, have been a driver in this initiative, at the same time promoting business transformation for its further development. This year's symposium is having a theme of call for action manufacturing transformation towards social innovation. Globalizing manufacturing industry is taking a bold steps to face up to the global challenges, which in turn demands international collaboration. Today, we have looked into sustainability as well as interoperability of information sharing. The third session is the expert session. Digital product passport, trust business model, and digital space for manufacturing are the areas where experts will make their contributions and interventions. I truly hope that this session will prove to be a worthwhile experience in their quest for the achievement of sustainable society. And with this, I would like to conclude my remark. Thank you very much.
Thank you, Mr. Majima. Next up, we will hear from Mr. Hess from the German Ministry of Economics and Culture, Climate Protection. So, Mr. Hess, please.
Dear Majima-san, please extend our warmest regards to Mrs. Sugar. Thank you for your intervention. Dear Kimura-san, Nakatomi-san, ladies and gentlemen, minasama, I want to thank the RRI for inviting me to give a keynote on today's Japan-German Expert Forum. The Platform Industry 4.0 and the RRI worked on so many topics in the last years. I'm grateful for the high quality and meaningful contributions to drive the topics forward. Japan partners became reliable and trusted for the German companies. Trust is of the essence, as we all know. And this year, I'm in Tokyo with the largest German delegation ever. Thank you very much for hosting us. This shows the interest to exchange on the topics, but also in cooperation with Japan and internationally. Since 2016, the successful German-Japan cooperation has mostly focused on the topics of cybersecurity, international standardization, and digital business models. It aims to promote Industry 4.0 to small enterprises, shared best practices on work, education and training, and supported several research projects. In addition to the expert groups, important pillars of the cooperation are the annual German-Japanese Business Forum at Hannover Fair, as well as mutual involvement in important events of the two platforms. Today, we are all committed to drive the digital transformation of our societies and industries. Key role will be the digitalization of global value chains as one of the key enablers for more competitive, resilient, and climate-neutral economy. Industrial supply chains and value networks do not end at sectoral or national borders. A broad approach is therefore required. The creation of industrial data ecosystems is a key development step. It will serve as foundation to transform industry across all sectors, as you can see on the chart. Artificial intelligence can serve as an example for a multi-sectoral approach. Solutions for industrialized large-scale AI applications need a secure and trusted environment for pre- and post-training. However, technologies like AI need to have access to a vast amount of high-qualitative data from different data owners. And secondly, access to sufficient compute and storage capacities. This, to my understanding, highlights the importance and needs of industrial data ecosystems in combination with sovereign digital infrastructure. The German government understands the necessity to incentivize and support the development of industrial data ecosystems in different sectors. We were able to establish a comprehensive support framework that allows for implementation of sector-specific use cases. As example, I would like to highlight Catena X as the frontrunner on the chart marked in yellow, but also Factory X and Aerospace X and all the other projects shown on the chart. Most importantly, together with many EU and global partners, we have launched the International Manufacturing X initiative to drive the globalization across sectors. The aim is to connect digital value chains and high-value data across industries and countries, to set up of the regulatory frameworks and stand-ups, to implement the global foundations for data-driven, resilient, sovereign, and climate-neutral production, to enable innovative value creation in an interoperable and sovereign data ecosystem. Ladies and gentlemen, the German industry is involved in these developments, and the federal government will make contributions to the successful development of the projects. But together, and only together, we will succeed if we are to join forces. Only together we can create the digital transformation based on our shared values. I wish you all a fruitful and successful forum today. Thank you for your attention. Arigato.
Thank you very much, Mr. Hess. Now we would like to move on to the presentations. In session 3, we have no time for Q&A. Therefore, if you have any questions about today's discussion, please go to the link on YouTube and go to the Q&A site, enter your question, affiliation, and your name in the name field. First, from the overview of the expert discussion, Mr. Nakashima of RRI will explain. My apologies. No, we are moving directly, rather, to the report from the International Standardization Expert Meeting. The title is Digital Passport, Circular Economy and Innovation. RRI International Standardization Support Action Group and ISST. Mr. Komoto will speak. Also from SPI 4.0, Mr. Gaiko in Germany will speak. Please start.
Good afternoon, and thank you very much for the introduction. So I'm Jens Gaiko from the Standardization Council Industrie 4.0. This is a German initiative to coordinate all the standardization activities for Industry 4.0 in Germany, including digital product passport and data spaces. And since 2018, I'm active and have had several times the chance also to be active here in the Japanese-German cooperation. And I will give the presentation together with Komoto-san from ISST.
こんにちは、産総研の河本と申します。私も
Thank you very much. And Komoto from ISST. Since 2018, I had been a member of the standardization group. Thank you very much for giving me this opportunity.
In German-Japan collaboration, we have since the beginning also a dialogue on standardization issues, because we recognized that IIoT or Industry 4.0 requires an unprecedented degree of system integration across border domains, hierarchy borders, and life cycle phases. And this requires also standardization work. So in the past years, we had studies on standardization and dissemination and discussed our future vision for smart manufacturing, including use case elaboration and substantive operation on asset-oriented information and function structuring. And of course, finally, the target is to have a harmonization and alignment of standards at the international level, namely at ISO and IEC level, and also at the relevant consortia standards, because in the end, we need all of them. Our presentation is structured into 10 areas. The overview is already given. Then I will give a background on the European regulation on the digital product passport and identify the requirements on the digital product passport DPP, and including utilization, what is DPP, and the initiatives involved in that. And then Komoto-san will take over the second part on the situation in Japan, towards the development of innovative DPP use cases and the focus of current activities, future work, and summary. In Europe, we see since 4 or 5 years growing interest in the so-called green and digital transformation. This was already mentioned in earlier presentations today. And in 2.5 years ago, in March 2022, a draft of a so-called eco-design requirements for sustainable product regulation was published. Acronym is ESPR. So if you look for more acronyms, you can use ESPR now on. So this draft was published and then discussed and commented, and since a few weeks it was adopted and is published. And this ESPR defines requirements for the digital product passport. And from 2027, the adoption of the DPP for selected products is expected. Here I have some slides. You can see they are copied from the European Commission directly. So this is material from EU Commission to explain what is the DPP. So DPP is an integral part of this ESPR and with the same adoption timeline and future work program for priority products. And it has also a timeline for product requirements. Here it says except batteries. Batteries is a special case because battery regulation is going in parallel. So therefore the batteries are formally excluded by ESPR, but as we heard before, the battery passport will be also mandatory for Europe, and this is from the content it is aligned. In addition to the ESPR, we expect a growing number of other EU policies that will rely on the DPP, for example, battery regulation, as I mentioned, but also toys regulation or detergent regulation, construction product regulation, critical raw materials, and so on. So we expect that this will spread to further regulation. The DPP will simplify digital access to product-specific information, and it will therefore, in the ESPR, there are requirements on the data provision, complementing the physical eco-design requirements. And it's not a track and tracing tool, but if it is implemented accordingly, it can be used for that. And the DPP system shall build on existing best practices at international level. Basically, this means ideally it will be based on international standards. Again, a slide from EU Commission. EU Commission distinguishes between the so-called DPP system, shown on the left side, and the DPP's data, shown on the right side. The DPP system is the how. How is the information provided, and how can the user, the customer, or companies access to the DPP data? And this is also like a IT architecture. And this here in the ESPR, there are some basic requirements on this, but the detailed requirements will be described in standards. And for that, the European Commission has issued a so-called standardization request. And again, ideally, we can base this on international standards. So international standards can be developed and then finally can be used to fulfill European requirements. And if we achieve this, this would be a big step forwards for the international supply chains. On the right side, we see the DPP data. So this is the question for which type of product category we need which type of information. For example, do we need for this clicking device, do we need the product carbon footprint, yes or no? Do we need information on the amount of recycled content, yes or no? This is a political decision and will be decided by the EU Commission. Here is an overview of different product categories which are under discussion right now. I have to say under discussion right now because it's not finally decided. We expect in the first batch of product categories, we expect energy-related products. We have also textile and footwear, but probably also iron and steel. It's not yet finally decided. Here it says the priority list is expected end of 2025. Just today I received a message that probably earlier, so in the second quarter of 2025 we will have a first list, but there was no chance to update the slide anymore. So, but still it's not finally decided, so unfortunately we have a kind of moving target problem. But what we can say is sooner or later all product categories will be affected by that. So maybe your company with your products is not affected in the first batch, but sooner or later it will be affected. On this slide, you see some requirements for the products coming directly from the eco-design for sustainable product regulations. Some of these requirements are directly related to the product, like durability, reusability, reliability, upgradability. So these are requirements on the product. Again, for example, here, this product has to fulfill this requirement, yes or no. Also presence of substances of concern and so on. If you go along the list, then you see some of the requirements for the product, but some are requirements to the provision of information on the product. For example, expected generation of waste material or environmental impact, including carbon and environmental footprint. So this is a requirement to provide information, and the tool to provide this information will be the digital product passport. Here is the timeline of the implementation. Again, as I said, the ESPR proposal was published in March 2022. And just a few weeks ago, the ESPR was adapted. It has the number 2024/1781. Maybe you cannot read the link, but it will be distributed under this link. You can download the ESPR text in different languages. European languages, I have to say, unfortunately. In parallel, the EU prepared a so-called standardization request. This is also published since a few weeks with the number M604, and it's also available on the homepage of the EU Commission. In order to fulfill the standardization request, the European Standardization Organization, CEN and CENELEC, have founded a Joint Technical Committee 24 for the DPP. This is a European Standardization Technical Committee. Nevertheless, the aim is to have it based on international standards because we are aware of the needs of global supply chains. And the last green arrow shows that we are not reinventing the wheel because we rely on standardization work on DPP in existing technical committees. For example, IEC 65 has done a lot on that. On the right side, again, you see the 8 categories of the requested standards according to the standardization request. Here on the bottom part, you see the life cycle of the products. A similar or very similar page was already shown in the presentations from Irie-san and from Tomas Hahn before. So this is the production life cycle from the raw materials until market placement and then repair, remanufacture, and recycle. If you look at the regulation, then you need the DPP from placing the product into the market. So the right side with the green text. For the left side, from a legal point of view, there is no need for a data space, but de facto you need a data space. So therefore, this is important to distinguish, to understand it. So upstream traceability is not the primary focus of DPP regulation, but the DPP concept should be able to cover these phases as well. So de facto, we need a data space. The alternative would be to send thousands of emails with Excel and PDF files, and that's no solution. That doesn't work. So we need a data space. But if you ask a lawyer or the EU government, they will say, no, from the regulation point of view, not needed, but from a business point of view, it is needed. So what we can say as key findings is the EU Digital Product Passport is a political concept and is decided, it will come, and it can be extended, and we expect it will be extended to further regulatory requirements, for example, such as quality infrastructure, so example for providing the certificates of conformance for a product. The DPP requires definition of what belongs into the product passport for certain product categories. As I said before, for this electronic device, it's a political decision whether you need product carbon footprint or amount of recycled material. So this is a political decision. Nevertheless, if the politics decides that you need product carbon footprint, we think this should, how to calculate the product carbon footprint and the semantics on that should be defined in international standards. Otherwise, again, we have a big problem for global trade. So that is important. So then number 4, the DPP should be standardized internationally to meet the requirements of global supply chains. And here I really appreciate the Japanese-German cooperation to get all the requirements also we have from your side. And the DPP system can be implemented with the Industry 4.0 concepts, for example, using the asset administration shell. And we call this DPP 4.0. But these other approaches are possible, but that's our recommendation, because if you use DPP 4.0, it fits to all the data space approaches discussed here today. And as said before, de facto data space is required to fulfill the regulatory requirements from the DPP. And International Manufacturing X can pave the way for these internationally interoperable data spaces. What did we done in our standardization cooperation? We started with a mapping of the organization and initiatives involved in DPP in Europe and Japan. So this slide, it's already quite busy, but far from being complete, and we will further work on it. So we see here the different initiatives for data spaces and for DPP on a generic level and on a sector-specific level, like batteries, electronics, and so on. And in our cooperation, we will further work on this, and hopefully we can publish this then as a mapping exercise. Also, we looked at the standardization activities here with a particular focus on Europe, because in Europe we have the concrete requirements on DPP. On the top level, again, you see the 8 sectors of the EU standardization request, and on the bottom part you see the other DPP-related standardization activities. With that, I hand over to Komoto-san. Thank you very much.
So first, let me follow up the explained situation in Japan toward the circular economy using digital technologies. First, in Japan, we have the basic act on establishing a sound material cycle society, and which was introduced in the year 2000 by the Ministry of Environment. Then, the Ministry has developed a series of fundamental plans for establishing a sound material cycle society, step by step. And recently, the latest version was released in September 2024. In parallel, in market in Japan, the Japan Partnership for Circular Economy was established in 2021 by the government, the Ministry of Environment and METI, and Keidanren. And Keidanren is known as a Japanese business federation, a major economic organization in Japan. The purpose is to enhance or to strengthen the public-private partnerships and promote the circular economy among various stakeholders. Several private companies have already proposed the advanced circular economy cases focusing on the data platforms. But these cases have not yet addressed the standardization opportunities and recommendations for data models, like in case of digital product passports. So let's turn our attention to the situation in the EU. So according to the SURPASS, which is the EU-funded collaborative initiative to promote standard-based DPPs, there are over 200 private and public initiatives related to digital product passports, some of which aim to provide product data-centric business solutions. Additionally, there are more than 300 existing and ongoing standards that are relevant to the organization and usage of DPPs, covering various categories, specifying functional requirements of DPPs and relevant systems. So let's imagine and let's consider the potential impacts of additional use case analysis focused on the usage of DPP and related standards. So first kind of impact is that such analysis, additional analysis of the use case, can provide an overview and relevant standards organized by the function of DPP systems. This is particularly useful for DPP-related initiatives that are developing business solutions. Secondly, it can enhance the interoperability across various business solutions and the implementation of corresponding DPP systems. So based on this background, let me introduce the focus of the current activities in Japan-Germany collaboration. So this slide shows the distribution of the existing contributions by SURPASS, the European initiatives, in terms of documents, which is organized according to the views with which the documents are written. So from a business, and the usage, and the functional, and the implementation. And it is also mapped according to the intended readers of the documents. Our current activities try to contribute to specific area by analyzing use cases and data models. I will explain the difference in the, but the use cases we study in this collaboration are different regarding the focus of activities in the product life cycle. But I will explain the difference in the following slides. And the data models we study will be useful for application engineers for successful implementation. So this slide captures a use case about application of DPP for improving quality and transparency of the refurbishment processes of smartphones analyzed by SURPASS. That study presented the barriers for realizing such an application. So these barriers are derived, for instance, from the lack of the monitoring data of smartphones, lack of transparency on the refurbishment process, and so on. The latter barrier could be removed by locally providing information in the current stage, so refurbishment stage of the product life cycle. But the former barrier will remain unless we provide the information available at, unless we provide the product data across the product life cycle. So the focus of the analysis offered by SURPASS was typically on the downstream of the product life cycle, typically in the usage stage and later stages of product life cycle. But instead, our collaboration activities will study the use cases for preparation and usage of DPP, focusing on the production activities and corresponding data models with DPP-related standards. So according to the interest of participants of these activities, standards to be studied may include those in various categories, such as unique identifiers, data carriers and links, and data processing and data exchange protocols and data formats. We will conduct this study through bilateral collaboration between Japan and Germany. So this is a tentative assignment of roles based on the expertise of the participants, but this can be changed flexibly. For instance, Japanese members contribute by studying production activities, specifically looking at the data attributes and the relationships that can help remove the barriers in downstream activities. Meanwhile, the German members focus on studying the interoperability between use cases at both production and downstream stages, ensuring seamless integration across different use cases. So in summary, interoperability related to the standardization of DPP-related data models may be useful for innovative business solutions. This is our aim. The Japan-Germany Standardization Expert Meeting currently studies, but not limited to, use cases of DPP and the corresponding data models in the production stage in context of the Japanese manufacturing industry. And as many speakers explained, DPP is one of the use cases for data spaces. So we are looking forward to the input, advice, and recommendations from you. Thank you very much for attention. And wir danken Ihnen für Ihre Aufmerksamkeit. どうもありがとうございました。
So, Mr. Komoto, Mr. Gaiko, thank you very much. Now, we would like to have a report from industrial security experts. The title of the presentation is Trustworthiness of Supply Chain, Value Chain. We have Mr. Ogura from RRI Industrial Security Action Group, Hitachi, to start his presentation. Thank you for the introduction. Thank you. My name is Ogura from Hitachi Inc. I will talk about Industrial Security Action Group and also AG3, PI 4.0. I want to discuss the collaboration between them. And as you can read from the title of the presentation, between Japan and Germany, we've had a lot of discussion. And that includes a large concept of security, that is trustworthiness. So we would like to introduce this trustworthiness as a concept. So Dr. Klassen, we were planning to have him with us today to present. Unfortunately, he was not able to make it for today. And yesterday I had a talk with him online, and he actually recorded his video presentation for this meeting. So please look at the video.
So, hello everybody. Many thanks for giving me the opportunity to talk about our work regarding trustworthiness concepts for supply and value chain. My name is Wolfgang Klaassen. I'm working for Siemens in Germany, and I'm engaged in the German platform Industrie for all. With me in this talk is Dr. Takashi Okura-san. He's working with Hitachi and engaged in the Robot Revolution and Industrial IoT initiative in Japan. So what is our talk about? Agenda is about history and achievement in Robot Revolution initiative and Platform Industrie 4.0 cooperation. We introduce about current discussion topics with a focus on trustworthiness of data, and talk a little bit about our current work on next steps. So we had a fruitful cooperation since 2017. We were able to issue during this cooperation 7 different white papers, mainly at the occasion of an industrial fair at Hanover in Germany. In our white papers, we were talking about the role of trustworthiness in supply chain. We were talking about organization and products regarding trustworthiness. We are talking about trustworthiness attributes. And last but not least, this year, we went into the discussion of trustworthiness of data. So our discussion process was focusing the first time of establishing a framework for trustworthiness and using concepts like trustworthiness profiles between different stakeholders, where we exchange information regarding trustworthiness expectation and trustworthiness capabilities in such a profile container. We were also looking at different trustworthiness topologies in supply chain. Topology means the construction of trusted domains and how trusted domains have to interact with each other. And last but not least, we were enlarging our view in terms of trustworthiness for value chains and networks, not only for chains and supply chains, but also for value chains and networks, with at the end focusing on the data issue regarding trustworthiness. So when we talk about trustworthiness, we at least should have a good definition about trustworthiness. What do we understand on this word trustworthiness? We were looking at existing standardization work in ISO IEC JTC1, working group 13, which is now establishing a standard which is called 31303, Trustworthiness Overview and Concepts. The standard exists in a working draft, and it defines trustworthiness as the ability to meet stakeholders' expectation in a verifiable way. So important is, and we are referencing here the notes of this definition in 31303, that different trustworthiness characteristics apply and need verification to ensure the stakeholders' expectations. And these characteristics can be reliability, availability. You see here the list. This is not meant to be complete, but part of the list is resilience, security, privacy, safety, accountability. Very important for us also integrity and authenticity. And this is why we say trustworthiness is on top of security. That is a more general approach than just security. And in terms of security, where we come from, there is a double role, a double relationship between trustworthiness. First of all, we need trustworthiness concepts to signal security properties along the supply chain. And second, we need security mechanisms to secure this signaling of security properties along the supply chain, with trustworthiness properties along the supply chain against attacks from the outside. So a double sense of relation between security and trustworthiness, and that's of course a very interesting point for our work. Then I want to point out here, trustworthiness is also very important in the context of governance, and under governance we want to understand these are the rules which ensure the accountability, the transparency and the fairness of organizations. And when we say organizations, this also applies to ecosystems like data spaces between different nations and in a global environment. Here we will need a governance which is applied to such an ecosystem, and this gives us the rules which assure the correct and reliability dealing with trustworthiness and security concepts. Of course, measurability and demonstrability by means of objective evidence is very important when we talk about verifiability, and this applies to all trustworthiness concepts we want to apply in the future. So when we talk about security and trustworthiness in supply chains, we were looking at the existing standards like ISO IEC 28000 or 27000 series or 62443, and or also anti-counterfeiting standards which come from ISO TC 292. And all these standards many standards already exist, but there is not a framework existing yet which provides assurance for multiple nodes in the supply chains, not only for one security domain or maybe, let's say, trustworthiness domain, which support automatic processing, which support interoperability and scalability, and of course, which help to preserve confidentiality and privacy along the supply chain in order to safeguard the business cases of the incorporated stakeholders of this supply chain processes. So we have to take into account different roles. We have to take into account different competences in the companies, in the stakeholders which are part of these activities, different responsibilities, and also different access rights to information about the involved product, services, and also data sets. We established such a framework and the discussion in the year 2023 in cooperation between Robot Revolution Initiative and Industrie 4.0. We introduced an approach to establish trustworthiness in a structured manner. Using the trustworthiness concept, we introduced different possible supply chain topologies, and we introduced how trustworthiness expectation and capabilities mechanisms are used to signal with properties to the specified partner along the supply chain. This work was fundamental for the development standard in ISO TC292, named 22373, with the title Framework for Establishing Trustworthy Supply Chain and Value Chains. So our work between Robot Revolution Initiative and Industrie 4.0 was very important for this activity, which is now in the state of this in ISO and will be published early next year. This activity was one of the recommendations which were written down in the standardization roadmap, Industrie 4.0, issued by German Dean in DKA, also issued in Japanese language, as you see here, and you can download this. These recommendations were very heavily influenced regarding the security of this security part of the recommendation, also from the cooperation between our two groups. And it's clear this roadmap gives recommendation not only on security, but on recommended and necessary standardization regarding Industrie 4.0 and smart manufacturing as such. And it's very important that it's realized when we want to have interoperability and multilateral data exchange for standardization of industrial security in this context, and also trustworthiness is inevitable for the success of these activities. Last not least, I want to point out the relationship to the digital product passport work, which has started now in European standardization body CENILEC JTC 24. This is standardization in regard to fulfill the European Eco-Design for Sustainable Product Regulation, short called ESPR. There exists a standardization request which has been adopted by CENILEC already. Security work was started in September this year, and the adoption for first products is planned for 2026. When we look at such a digital product passport, this passport will contain data and information about products and organizations which will be supported along supply chain. And this data need, of course, globally accepted proof of trustworthiness. This is very important, regardless whether it's just a European regulation or regulation from any other country, because we are on a global scale. We are working together in our supply chains. And so it's very important that we have international standards, internationally and globally accepted standards, which deliver trustworthiness and security for our processes along the supply chain. So thank you very much. And in this case, I will hand over to Ogura-san, who will talk about the second part of this presentation.
Thank you very much, Dr. Claassen. Now, let me skip what you've already seen. You have heard about the past activities and the outcome. Now, I, Ogura, will explain to you the current situation. What are the discussion topics that are being currently talked about? Now, this morning, you've already heard and you already know much of what is on the slide. But more recently, the manufacturing, production, and use from supply chain to recycling or remanufacturing included. Very broadly, the entire product cycle of a product is taken into consideration in certain business models and business activities, and we call them value chain. And the slide shows battery recycling as an example of a value chain. Within this value chain, you could have DPP or utilization of other data spaces, so that the value you can obtain from the value chain can be maximized. Or maybe there's no data to begin with. Unless you have data, you will not be able to capture value out of this. So in the value chain, we like to achieve recycling economy, and we focus on data. In the past, products or organization had been the main play, and the discussion had mainly about the establishing trustworthiness of data and organization, but now we feel that trustworthiness of data is also necessary. That's why we have been having this discussion. Now the slide shows the definition of trustworthiness of data. The point I'd like you to focus is that we separate trust and trustworthiness. Trustworthiness has an extent or the scope, and on various perspectives, stakeholders are expectant from others, and how much can they respond to the expectations, how much you cannot respond to expectation. We are talking about the degree and the data products and organization. What will be the level of trustworthiness, or can trustworthiness be established or not? That's been the definition. On this trustworthiness, the expectations versus response to expectations. Trustworthiness expectation and trustworthiness capabilities is the topic. And based for data, what is available, what can be used, and what should be used. That is the nature of discussion we are having. Now, data trustworthiness, as you consider this, there are 2 points that we need to keep in mind. The first point, and for a product it could apply, but when it comes to data production, storage, and utilization of such data, could be done by very different stakeholders. Even within a supply chain or value chain, these activities may take place in different sectors. Therefore, whether the data is trustworthy or not, its capabilities and expectations would include information as to where the data was generated, how it's used, how is it managed, was it appropriate. Those aspects will need to be confirmed. The slide shows the data being present at various different positions, locations, and an operator may want to use data about the residual electricity in a battery. If there is a battery by a manufacturer, you request manufacturer to and ask how is battery made. That information may be confirmed, and the expectation is that you will be supplied with the data. But the bottom, the battery is the supplier, and the battery data, the residual data is what they want to use and do business. Whether that data is adequate or relevant, how was it obtained or produced, how was it transferred, how can the data be used, those are the points that operator would like to confirm. So where is data, depending on where the data is held, the trustworthiness of data will need to be established, but the expectations to be confirmed would change depending on where the data is held. The second point I'd like to mention, rather than a product, when it comes to the data that could be that's transferred, frequently how the data is used, the producer or the original holder of the data would have expectations as to how the data will be used. So if you look at the left, we are showing you the example of a product. How will it be used? Requirement is issued, and if adequate requirement comes, you can trust the data. How is the data used? Is it adequate? For the provider's part, they do not want data to be used without any control. So for the data issuers, there are expectations or requirements, rather, that we'll need to keep in mind. So mutual expectations as well as capabilities will need to be exchanged. That's the characteristic aspect of data. Now, based on these 2 points, currently we are having a discussion. Well, we still have not reached an agreement between Japan and Germany, but these are the 7 perspectives where expectations and capabilities clarification or the clarification of concepts will be discussed in the future, especially concerning these 7 points, especially 5, 6, 7. These are based on the 2 points I just mentioned to you. Conclusion or summary, and what will be the next steps. IIoT supply chain, value chain, trustworthiness establishment has been the focus in collaboration between Japan and Germany since 2017. As for the framework to establish trustworthiness, we have been discussing, and the concept of trustworthiness is to be organization, product, and data. We have expanded the scope, and currently we're working on data. Our activities or our white paper is in accordance with ISO, IEC, ISO, IEC, JTC1. We will comply or follow this in our activities. What will be the next steps? I'm repeating myself, but we are discussing further the establishment of trustworthiness concept for data, and including use cases. We'll have a very solid discussion so that in framework or something similar to framework is what we'll hope to establish. And the outcome, we hope to be published at Hanover event. And we have been discussing data specifically. Your comments, opinions, collaboration on our activities is what we hope to receive, especially when it comes to data space. Those people who are interested in data space or who are already working on data space, for realization of data space, we are confident that you need such trustworthiness. So we are hoping to receive comments and opinions from you. And this concludes my presentation. Thank you very much.
Thank you, Dr. Uda. Now, Business Ecosystem Expert Forum member is giving us a presentation entitled Collaboration on Business Model. Our first, Dr. Shuhei Sugie, Chairman of Business Model Task Force RRI, Director of Open Innovation, and Professor Dr. Nils Medea, Platform Industry 4.0 Working Group 6, who will be joining us online. So Dr. Sugie and Dr. Medea. Thank you very much for your kind introduction. I'm Sugie from Future Corporation. So we have two more presentations, and we have had a very long day, but I would like to give you a fun-packed presentation on business model. First, I would like to discuss the background on Japanese initiatives in this area, and Professor Medea will take the second part. This initiative started just this year, so we are yet to arrive at a conclusive goal of our initiative. That is why we look forward to receiving your inputs and opinions, especially during the networking session that follows this symposium. First, why are we doing this at this point? There are a couple of background factors. Back in 2018, at an international symposium, Dr. Kagurman proposed our cooperation in promoting the B2B platform economy with a European and Japanese perspective, and that is how this initiative started. In 2021, we formulated a report, and after a period of hiatus, this initiative resumed at a full throttle this year. In 2018, sorry that this slide is a bit busy, value systems were evaluated. Red is the U.S. situation, and blue representing Asian or Chinese market, SAP in Japan, and there isn't even a flag of Japan in this bubble chart. So this was the situation in 2018, and we really have to fill the gap. No matter how beautiful the product is, how widely the product is sold at a global level, digital giants are just monopolizing all the profits and the creams of the business. And all those giants are the ones who are having oligopolistic business model. And they are the ones who also have all the data. That is why we really had to seriously consider digital business model. And that is how we started our German-Japanese collaboration. This is a report formulated back in 2021 that can be downloaded from our site. And towards 2024, Japan also had some contemplation, which I would now like to introduce. So Dr. Kagurman made a proposal in 2018, and 22, 23, and 24, 3 projects have been driven. which is together providing the basis of our activity. As of 2022, the concept of death of competition, quarter a century ago, or more than 25 years ago, this was something that was presented, and we scrutinized this document as well. And why the death of competition happened. Business ecosystem was first referred to in this document, so we try to deeply understand this concept of death of competition. Up to that point, it was more like a competition between individual companies, but it has now become the period of ecosystems. I thought that this was a document that was so well written. One big lesson I found was summarized here. There is a layer of business. Outside of it is the society, and outermost layer is environment. Different ecosystems are intertwining in this mass of layers, and that is what we call a business ecosystem. At different occasions at RRI, we also have scrutinized different layers of ecosystems to analyze the linkages between and among different factors. So that is what we have been doing at RRI. And another activity in 2022 at RRI was inter-academic collaboration. JSRP and we have been working together. Professor Takanashi of U Tokyo, JSRP's Dr. Onuma-san worked together. The focus of our work with Professor Takanashi is the value creation. New business digital model. What value does it present? So that was the discussion on the upside. And we have studied all those scenarios. At the bottom, the joint project with Mr. Onuma of JSRA are about the development of infrastructure or other fundamental issues from a viewpoint of business model. So these are the two areas of collaboration that we have pursued with academic partners. And these are also the areas that are thriving as well. Last year, business ecosystem in the area of digital was also the focus of our activity in 2023. In the era of digital, what is the innovation? Led by Dr. Mizukami, we have analyzed a business model, for example, of Uber Eats. One of the understanding is the standardization of interface facilitate business process collaboration, thereby dramatically changing a business model. And that was one of the major learning. And say, for example, there was a Uber Eats. There had been a food delivery system that preceded Uber Eats. You used to call a restaurant or stall, you place a phone call in a very analog manner, placing an order for your food delivery. That also means that you really have to know about the menu of the restaurant, and the restaurant needs to know where you live. And that is how the business transaction was ensured. But with Uber Eats, these kind of transactions were standardized, widening the options for consumers and also for the restaurants. So that was a digital-driven innovation that was made possible. Learning these positive impacts of business models, we started joint exploring new business opportunities. And that is the activities that have been pursued in Japan.
Explain Japan activity.
皆様こんばんは。
Hello, everyone. This is Niels Madea.
Here at the symposium. My name is Niels Madea. I feel honored to be here tonight, at least virtually. I would have loved to come in person, but unfortunately that was not possible. So it's my pleasure to give you a brief overview of the activity on the German side here, specifically the activities of our working group 6 of the National Platform Industry 4.0, and also to share some thoughts about the future collaboration, as Sugiya-san has pointed out. At the moment, we are at the stage of reviving our collaboration. Here, we've had discussions for about a year, and we are still thinking about the path forward. So, Tsugi no slide onegaishimasu. Hi, thank you. So, okay, a brief overview of our working group and. What is the purpose? What do we do? And how do we work? So as it says here, our mission is to rethink value creation specifically based on the principles and technical or technological concepts that the Industry Prof 4.0 that it provides. And to lay out the potentials lay out the potentials and help create conditions to proliferate these concepts so that hopefully many players here in our economy can apply them and can profit from them. So the two questions that we are after in our working group generally are, first, how can Industry 4.0 concepts help or support existing business models, specifically when looking at the industrial sector, manufacturing and the like. So how can they support existing models, and how can they help create or generate additional or new business models, help to serve new source to serve exploit new sources of value creation and transfer and monetization. And the way we work is typically whenever we find existing topics to address, we form subgroups, or sub-working groups in our working group, which has been the case recently or over the recent years, where we have formed 3 working groups, one focusing on the specific aspect of sustainability, another one that took a look at the industrial metaverse, and next one that has been looking at value creation specifically in data spaces. In general, our working group comprises more than 60 members from various stakeholder groups, so from academia as myself, also from industry, from various associations, also labor unions and the like. We have I would say we represent a broad stakeholder base when looking at these topics. Okay, so having said that, I would like to move on to the activities of our first subgroup, so to speak, that took a look at or is still taking a look at the concepts of Industry 4.0 and sustainability. Here we had we looked at various aspects. First, what we did is we conducted a little study to investigate how Yeah, well, digital business models, specifically those those related to Industry 4.0 concepts, how they could impact sustainability goals or sustainable economic activities as a whole. From which the working paper you could see here resulted, that has been published, and yeah, if you want to, please take a look at it. And more recently, what we've been discussing for the last, for the last year or last 1.5 years was the aspect, well, how can companies, how can they organize their activities related to sustainability, and how specifically, where should they, so to speak, locate this responsibility for sustainability initiatives in the organization. And there we looked at various case studies from different players in the industry, and came up with, well, I would say a variety of options where companies can, well, locate that responsibility within their organization. And we're still working on that. Next, please. So another subgroup, another subgroup has taken a look at and studied the industrial metaverse. As you all know, the metaverse is a concept that has attracted quite a bit of attention in the consumer space. So we asked ourselves, well, what does this concept mean for industrial players, and how can they make use of it? I would say for serious purposes, for serving as a locus for conducting business. What can companies do there? And there we came up with a couple of use cases. We proposed a number of activities that could be, I would say, relocated into the virtual space of the metaverse. The results of this have also been published here in a working paper that's available for download. And actually, only very recently I learned that we want to continue our activities in this sector here and spend some more attention on this. Next, I would like to show you some thoughts. On the data spaces. Our subgroup on data spaces that have also been have also received quite a bit of attention. How they can be organized, data spaces as a concept. We've also heard quite a bit on them from previous presentations. And I think it's quite well understood how they can be organized. The sets of rules have been proposed for setting these up. Organizational concepts, ownership for them, control over them, and the like. Yet, the question that is still lingering there is, how can we make sure that companies actually make use of them? These are nice concepts, but they are of no use. They don't become effective unless many companies use them. And it is one thing to get larger players to become engaged in them, publish data, offer services, consume data from these kind of spaces. Yet, in our economy, as well as in your economy in Japan, the vast majority of companies are small and medium enterprises. And the big question is, okay, how can we get them to, well, access the data space, embrace the concept, make use of them, also offer their data and consume them? What is in for them? What is in for them? And related to that, there have been a number of studies have been conducted on our side, and that also brings me to the next part of our presentation here. Based on that, I mean, we've had between our working groups here, on the Japanese side and the German side, we've had 4 or 5 rounds of discussion now, where we showed each other what we have been doing so far. And actually, what my personal impression is, what resonated quite well here was the aspect of bringing concepts like the data space to small and medium enterprises. And can we move on to the next slide, please? Yes, and so where we found a big, I would say, area of common interest, and that is, okay, how can we go about, how can we target small and medium enterprises and get them to embrace concepts, Industry 4.0 concepts, specifically the concept of data spaces. So what we are actually, and that is what we are actually thinking about right now, looking at, well, the large amount of companies that we have in either country, study how, to what extent they're already engaging in data spaces and what we can do to get them more engaged, and, so to speak, to scale data spaces across countries, especially across Germany and Japan, or Japan and Germany, despite the various differences that exist. And we also want to look at specifically at these differences and see, okay, what do we have in common, what is different, and how can we still scale data space, because our countries are in a quite similar situation, as we have learned. So this is what our thinking revolves around at this stage. And I hope that we can gather some valuable input here from the audience, also following our presentation here. Having said that, I would like to hand
Thank you very
back
much.
over to-
それではですね、
So, from here onward, as Niels talked about that collaboration, he talked about the conclusion to conduct the collaborative research. So we do the research and we understand digital business model. But with that understanding alone, we will not be able to solve problems, to improve services, to satisfy all the consumers in the world. And that's the kind of world that we want to build. With that in mind, we do our research and we will identify challenges, and then we'll think about how we can respond to those challenges. And we want to do that with all of you. And data sovereignty, and as we discussed, DPP, these will be the essential foundation. On top of that, we have to consider the business model. So consider where we can collaborate. We want to find areas where we can collaborate effectively. Task force number 4 have multiple diverse members representing academia, who can contribute ideas, manufacturers, consultants. And we want to join forces of these different stakeholders and see the common area, this overlapped area, where we want to launch international joint programs involving all of you, of course, so that we'll be able to make progress in expanding our business activities. And starting point is the survey, the research we want to conduct, targeting all of you. So after this, the members are asked to participate in the survey, and we'll share the results So next year when we have this symposium, we can share with you the outcome and plans for the future as well. So please look forward to that, and that concludes our presentation. Thank you for listening.
杉江様、丸谷先生、どうもありがとうございました。続きまして、産業データ連携専門家。
Next presentation is on the Robot Revolution and Industrial IoT International Symposium 2024. Mr. Ingo Sawela, Trump, MT, SE, and Professor Shinsuke Kondo. So floor is yours, gentlemen.
Good afternoon, I'm Kondo from the University. Good afternoon, I'm Kondo from the University of Tokyo.
Ingo Sawela, till now 29 months at Trump as a research manager and responsible for a head of manufacturing.
Today, we would like to share with you on the topic of manufacturing data space as the booster, as a topic to share with you. Now, this is what I'm going to tell you today. We have started this activity last year, and I will briefly explain to you what we have done, and then talk about what data governance is. Then, what are the activities on data governance, what researches are taking place in Germany. Also, we will share with you the situation on data governance, the activities in Japan, and what we should do in the future will be presented in our summary. First, history. What have we done so far? In Germany and Japan, we have collaborations. It started last year. Now, concerning our data space, both in Japan and Germany, we have had certain activities which we have decided to share and then discuss and see what specifically we should do. That's what we have explained in the RRI Symposium 2023. So we gave you a preview as to what we would do, which was followed by the discussion within the team. And during the Hanover Fair this year, we published our discussion paper. If you have not seen the paper yet, this is going to be very helpful for you, so we hope that you will go through them. Now, within the discussion paper, first of all, we talk about the core aspects and design elements for manufacturing a data space. We mutually discussed and identified what would be the core aspects. For example, data integration and governance would be very important. We also thought that we cannot miss interoperability in the discussion. Just having raw data is not sufficient. Therefore, semantic understanding and ontology need to be linked with raw data. Also, data sovereignty and data security would be an important topic. Technology developed, therefore, along with the technological advancement, we have to have a good system, and that will evolve along with the development, and those will be the design elements and aspects. What is important here is that the data space will not progress if we only focus on technology. Data sovereignty, data security, and the mindset, which is the periphery of technology, will also need to be taken into consideration. Now, in Germany and Japan, we are to create data ecosystem. But first, we need to summarize what had been done in the past and what are the priorities. That's the summary in the publication. Today, we'd like to briefly talk about data governance. First of all, what should be the data spaces? What are the expected format of data spaces, it may not be consistent among different regions. The slide shows vertically and horizontally. Well, horizontally, you're looking at the function of database space, whether it's rich or very simple and minimal. Vertically, we are looking to see the participants in the data space and to what extent in data governance and management, data culture, are they ready? So the readiness is represented. If you're higher up, you are ready. Lower down below, you are not ready yet. So when you look at those dual axes, various applications and regions, depending on where you are, the position of your application would vary. It could be quite diverse within this space. For example, left bottom, written in red, it shows that participants are not ready yet. However, because of certain reasons, they must engage in these efforts. For example, the regulation may already be in place and they need to respond. In those cases, the participants may not be ready, but they must engage. So on the side of the system, although they may not be ready, they should be they should start to work. That means you have to give rich system. But further down in blue, there may be no regulations, or the function, the data space, may not be rich yet. However, participants are very much interested in data governance and data culture and management, so they are ready. So when they're ready, like the management or data space applications may be offered. Within these 4 quadrants, what would be the data spaces required? What are the attributes of the data space? It would vary depending on where you are. In other words, data space would not be consistent depending on the applications or the regions. That format would vary. So there's no consistent data space. It could be a variant. And based on this concept, we would like to discuss what data governance would be. Now I'd like to ask Inge-san to tell you about the activities in Germany.
So before I start to talk about the activities on our German community, I will say a big thank you to Nakashima-san and his colleagues, to Professor Kondo in our collaboration meetings. And I will give a short inside view what my experience in this collaborating meeting is. So as I look back in the past, maybe we have several meetings, we talk together, and I look back, we were very serious, very formal, and we have a shy conversation about the thinkings. And after a while, we discussed about these things, what is the next step, and what is necessary to build up this infrastructure on manufacturing data spaces. We talk about, like Boris Otto explained in the morning, it's more than technical, it's about culture. And after a while, and that is what I experienced, so we get in trust, human to human, we get in trust together, and then we begin to laugh. We are not more serious and shy, we have trust each other. And so we talk about, and I ask the colleagues, also Nakashima-san, did you know about the quote from Peter Drucker, like culture eats strategy for breakfast? So it's a book, it's an idea. And we think about together, and so we talk, and if we retransform this quote, we come to the idea, maybe data culture eats data space for breakfast. And I extended, but with data governance, it tasted better. And then we laugh more, because the idea was not so bad. And so we learn together. It's not only a technical thing. The technical thing we can solve together, so we see trustworthiness, infrastructure, and some things. But we have also talk for the people to understand what's happened, because it's not a change. So we have not a change, and then after a while the old system will working. No, we have a really global transformation in a new era that we have to understand, and we have to learn it together. And as for my understanding and for our understanding, also we get new skills. We have to learn how to handle data, we have to find new roles, and we have to train our employees all over the world. And then we find out that data governance is an enabler for the data culture and to change. And that is what I say in the beginning. Then I talk a little bit about the activities in Germany. For the moment, you see here the most important data acts, or the European data acts, who are in force. They are in force. And now we have a little bit time, about 12 or 15 months, and then different regulations will be operational. So the organization have to learn a lot of how to implement in the processes, how to implement what is to interpret what the law is. And it's not only the Data Act, it's also the AI Act, it's the Cyber Resilience Act, it's the NIS2 Act, only in Europe. And as a global company, we have a lot of more regulations in the Asia room, in the American room, and so on. All the societies build up some regulations and to how to manage this data things. And for a company, it will be very hard, because our business model is to build machines and to sell machines for our customers, not to fill out some reporting to some government things. But we have to do that. There's a chance also, because we can now transform the organization in case of this kind of acts. And so that's a little conclusion about the perspective in this. So all of the enterprises have to understand the new regulation. So I have a lot of discussion with my colleagues. So how to interpret this text, how to do that in the implementation in the organizational processes. And it's a very hard discussions, because you have to find out what means this. And we have also cybersecurity topics. So you see that in the Factory X product change notification use cases, and a lot of things are very new for us, because we have to learn that, what means that, and to implement it. And we see also that the government have the same problem, like the industry, because the government have a different new laws also to implement it in their organization, and the colleagues from the government and the other side have also to think about how can we do that in our organization, how is the interaction with the industry. And till now we have some conflicts in the interpretation with these different kinds of laws, and we have to find out how to solve that. It's only in Europe. It's a very interesting thing, and this is a well-known picture. So it's a very interesting picture. Why? So if you started by Thomas Hahn, Klaus Otradowitz, and other guys, we invented this picture, and we have no idea what that in the future brings. But in this picture, I take a lot of explanation. How can we develop some kinds of question in this? So, and there's also, if you look at the border side, the regulation framework, we have an abstractic layer here, and you can use this picture all over the world, because regulation is all over the world. And so we can find out which standards come together. And other good thing is that we find out that the projects like the Factory X or the Catena X project will be interacted with the regulation. So, and here we can start a discussion all over the world with this picture. So, and why we need a Manufacturing X Guidance Board, it's only necessary to synchronize all the German Factory X or X projects, because each of the projects have some questions of data governance and data assets. And we have to find out how can we manage that in a similar way. And we have to check out the in-house data catalogs, and a lot of each of the companies will do that or have to do that. And each of the companies find individual solutions for that. And we have to synchronize these individual solutions to get a speed on the track. It's a very interesting thing. And as I said, data governance is an enabler for it, because data governance focused on the data as an asset. And we have to define some data governance rules and what's happened in Factory X. So we stay with a lot of companies inside the consortia. And after 2 weeks, 3 weeks, the colleagues come and said, oh, how can we manage the data in our synchronized project? And then we said, okay, we have to some guidelines, like this data is understood as a value. And there's a clear responsibility for the data. And such kinds of rules we defined at the moment. It's ongoing. But as a result of this ongoing discussion, we will get data governance guidelines. And that's a good thing, because we can collaborate in these points. Maybe we find different kinds of other questions, but in the Zoom, we have maybe an international data governance guideline. And this will be accepted in the whole industry, and that's an important thing. And at last, we have seen some kinds of presentation about trustworthiness data. I have made also a very, very, very simple example what could be happened in the future. What could be happened in the future? So you see here also the process, and I have I said, okay, there's a mining to get raw materials, a company A. We have some intermediate products, for example, a battery, company B, and we have a manufacturing company who supplied from company B some kinds of batteries, and so on and so on. And then we have a customer, they used this battery, and at the end we have a recycling company who recycled the battery. And we're thinking in our project about data governance, and also with the DPP, for example, which kind of data have which classification. So classification of data become maybe in future very important, because we have to find out which kind of data are restricted, which are trusted, and which are published. And here as example, if the company A have a raw material like cobalt, and they wouldn't talk about, so we have a restricted thing. If a company B used this material, he has no idea about this raw material cobalt, for example, because he produced batteries for that. And what did the engineering do? They make some specifications about their product. They said, okay, my battery will be 1,000 charging cycles. That's my specification. And the supplier, the manufacturer, take this battery in his product, and he needed the specification, and he know, okay, this battery had 1,000 charging cycles. And if the manufacturer bring this battery in, for example, a car, he make other specifications, because the car said, okay, my battery has only 300 charging cycles, but the battery has possibly 1,000 charging cycles, but the customer didn't know that. And then we bring this to the customer, they use it, and they count the cycles. So they know, the customer know, okay, I have only 300 cycles, and actually has 58 cycles, and so on and so on. It's very clear that we have to think about what's happened with the data, what is published, what is trusted, what was restricted for the IP. At the end, so I'm not a good PowerPoint designer, at the end, we have to bring up this process in a circle. Because what's happened, if the company E have the specification And the actual value of the battery charging cycle, he gets and he recycle the battery and get cobalt as a restricted data. And what's happened if he know the recycling thing and could be make a offer to the battery company who built the battery. So the battery company has then the situations, oh, I have a mining company and I have a recycling company. What can I do? What can I change and what can I talk about? And that's a very deep impact in the simple example. Why is it necessary to make a data classification in the future and to bring out this kind of data governance we developed at the moment? So I give hand over to Professor Kawada-san.
Okay, thank you. Yes. Okay, so
Okay, allow me to speak in Japanese about the activities in Japan. Today I will be discussing briefly government organizations' official data governance related documents. I will start with official documents by the government and then suggest what is lacking in these documents. Official government documents, there are 3 kinds of them, and these are the hard copies of each. It is very thin, meaning that it is not yet substantively rich. There still remains lots of flexibility, but this can be the baseline of data governance as presented by the Japanese government. Let me first tell you what is written in these documents. First, METI has formulated the Digital Governance Code 3.0. This document gives a demarcation of the requirements in trying to achieve digital governance. On the right are the 3 visions and 5 pillars from bullet 1 to 5. So 3 viewpoints includes the linkage of management vision and DX strategy. And you really have to quantify and review as is situation and to be situation. And third vantage point is the need to embed these goals in corporate culture. And 5 are the requirements required of businesses. Management vision and business model first needs to be formulated. And based on these, the strategy needs to be formulated. And in promoting the strategy, performance needs to be assessed by using indicators to measure the DX strategy is leading to a positive outcome. So that is the gist of this document. So I wouldn't go into the details of this, but what needs to be done is listed under the Digital Governance Code. In this document also have created a system to give a certificate for companies that meets all these requirements. The second document is Data Management Handbook for Corporate Executives. As written on this slide, data-driven management requires the executives to know certain things, and that is summarized in this booklet. So what steps to be taken in which sequence can be found in this book. Preparation stage would include such steps as the understanding of the corporate executives to understand the importance of the information and data literacy and other data-related capabilities to be enhanced. At the same time, creating a catalog of data. And data policy needs to be formulated so that data can be collected based on the policy for better utilization. And the third document is more specific than the second. It is Chief Data Officer Handbook as to what is required for CDO and what values can be brought in if you install a CDO. In this booklet, you can find data-based decision-making from the top to bottom of an organization, and that should be embedded as part of corporate credo and culture. Chief Data Officer, if he or she fulfills such a responsibility, what can be achieved? So the benefits of having a CDO is summarized in this booklet. So CDO needs to deliver substantive information. At the same time, technological social changes are grasped so that needed responses can be made. Digital transformation based on data. These are the benefits that can be achieved by having a CDO. So we have such documents provided by the government. But now, suppose that you're in charge of implementing a DPP. Can you really achieve that? As Ingo mentioned, reading it and doing it are two different things. Component data, for example, where should I keep such data in my system? And how can I ensure that the information I have is trustworthy? How can we verify the trustworthiness? Suppose that you need to calculate exact energy consumption. What calculation or formulation can we use? These questions are often difficult to be answered. So you really have to have a reference use case for you to achieve all these tasks.
Very fast. Actually, we have to adapt the structure, the architecture, the processes for the new circumstances. Organizations are at the moment very busy to adapt all the kinds of stuff we talk about. And as Professor Konderson talk about, we have to find out which information in which infrastructure we have to handle. That's the thing. So as Sebastian Schneider said, participate, participate, participate. So feel free, and here's the invitation. We have to come in the dialogue to get it more faster. Thank you very much.
Professor Kondo, Mr. Savila, thank you so much. So with that, we would like to conclude session 3. Please give another warm round of applause to all the speakers and panelists. Again, this concludes the lectures, and this also ends RRI International Symposium 2024. I'd like to thank all the sponsors for your support to make this symposium possible. Online participants, thank you for joining us today.